bubbling again. Dr. Solerian at the console, beaker in hand. Andrew's in the lab coat. Samantha sealing the bags. Let's go. I don't drip, my LC floods thick sludge. Brewed in the lab where the pressure don't budge. Got the broth on spin, Thor plate torque. Amber glows like a harness, the forge. Spawn rack stack, yeah, rack to the ceiling. Sawdust base with that deep grain feeling. This ain't your buddy's half-baked mix. This is Elixir, the real lab fix. Elixir on deck, culture gone rogue. Syringe to the bag, now watch it explode. Keep spawning culture, it's more than a phrase. It's a whole lab world that we set ablaze. Sterilize first, don't mess with decay. Unless you breed mold, then...
Well, hello, everybody. It is Andrew, and welcome to our class, What is a Mushroom? No, I'm just playing. We're going to be joined by Dr. Ed Grand here in just a minute. I just wanted to quickly get on and say hello to everybody and let you guys know that I'm really excited about this class, and we're going to be hopefully learning some cool stuff. I will be in the background, so I will not be here for much of this class, but I will be listening. And Ed, if you can hear me, if you need anything, you can just let me know, and I will try to make sure that I am there for you. Yeah, I guess that without further ado, I'm going to introduce Ed. So, hey, Ed.
Hey, how's it going?
It's going well, man. How you doing?
I'm doing pretty good. Pretty darn good. Pretty excited, actually.
Good. I'm glad to hear it, man. Me too. Ed and I have not had much of a chance to talk, so before the class. Yeah, Ed, so I don't know if you heard me or not, but I'll be around. I've got to prep. Unfortunately, we're going on vacation tomorrow morning, so I got to be packing and stuff. But I'm going to bring you with me wherever I go. So I don't know exactly how much control you have over the software as the guest.
I'm not sure too. I hope I can at least show a PowerPoint. So I got some Google slides. I hope
you can. Do you want to see if you can do that real quick? Like if you can add it to a screen or. I think you can. I think
yeah,
Sam did that last time.
So share screen. Let's see. So let's see. Yeah, hopefully. So can you see my slides there?
I can't see them, but you might have to hit add to stage at the bottom.
Yeah, I did the yeah, I've never done it this way before. I might have to. Yeah, let's see. Ooh. It's got another window separated here. Maybe present. Slides and PDFs.
Yeah, so for me down at the bottom, like I can hit like add to stage like that, and it pops that up at the bottom. There's if you hover over the tab, that's from my angle. I don't know what it looks like from your side. So
yeah, gosh, I haven't done it this way before. I'm usually the one who has all the control.
Let me try doing it. I'm gonna click something. I think it's gonna kick me out of the screen, but you can try it. Hit this. So let me see what happens. I don't know. Oh, I think you can still hear me. Yeah,
I can hear you.
Okay. Does it give you the control when I do that?
No. There's the things at the bottom that say share screen slide.
Yeah, if you hit that and you look over, I mean, you can see my face and your face, right? And then can you see the box with your slides in it?
Yeah.
Can you hover over that and does it say add to stage?
No. It just there's little three things that just says stop screen and edit.
Okay.
Edit name.
Okay, so it might so you can share stuff, but I'm gonna have to be the one that pops it up, I guess.
Yeah, or I don't know, you have to like give me control or something. I don't know how it works on StreamYard.
Okay, give me 1 second. Guys, bear with us for just a second while we figure this out. So camera, general, guests. Guests can stream to their own destinations. Guests can see your comments and posts. No band guest. Okay, yeah, give me 1 second while I get that figured out. But the if you upload everything, let me see this. Like if I add that to stage, like that.
Yeah.
Is this your only slide deck that you've got, or do you have multiples?
That's the only one.
Okay. If that's the case, then what I might be able to do, is so kind of like that, and then you can probably try exiting out of that real quick. Okay, so it would bring you back to that. So if I add that for you, you'll be able to interesting. I wonder if you can hide it or not, or if it's going to be there the entire time. And is that something you're doing at the beginning? I'm trying to figure out how to give you permissions, but it won't.
That was kind of my outline for the whole thing. I mean,
so you're going to the whole time.
Yeah, I was going to kind of use that as an outline.
Okay, cool. Then I'll just, I mean, I can just, if it worst comes to worst, I can just pop it up for you, and then I can walk away. And as long as you don't close it out, you're good. And if you close it out, you can tell me, and I can pop it back up.
Will I be able to forward the slides to go through the slides?
Yeah, you should be able to. Let's try that again real quick. Load it back up, and I'll pull it up, and you can test that. Yeah,
because I was planning on drawing on the slides also.
Yeah, I think that'll work just fine. As long as I think I can control is closing it down and sharing it. So, let's see. So it's saying that I can give you permission to do it.
Yeah, I think that's what you might need to do.
Yeah, I'm just trying to figure out how to do it real quick. So it says that you can use the present button at the bottom of the studio to share their screen. If the guest shares Google Slides, both the host and the guest can through the slides. Yeah. I mean, that's what it looks like. It looks like I'm the one that hits present, but then after that, you have total control of it.
Yeah, I think that's the way I've seen other people do it.
Okay. So there we go. And then let me just... Okay, cool. So if I remove myself, it puts you right there and gives you control over it. So go ahead and try moving, like pulling up a slide and drawing on it or something.
Let's see. Okay, here we go.
Oh, cool. Okay. Yeah.
So let's see. Can I go through? Can you see me forwarding through the slides?
Let's get to know each other in the next techniques. Yeah, you're going right through it. So the only thing I'm wondering about now is if you can actually draw on it.
We can try right now.
Okay.
Let's see. I just figured out how to do this earlier today. Turn on the pen.
Yeah.
Can you see it?
Awesome. Awesome, man. Well, it looks like, okay. So yeah, I can just leave you with that, and then you'll be good to go. So
cool. Yeah.
All right. Well, I apologize for the technical difficulties, everyone. I just, I had not had time to get with everything going on to get together with it.
So let's see. So I just got to go back here, and then you can see the red squiggle again.
Looks like it. I mean, I can still see the squiggle.
So as long as I don't press stop sharing, we should be okay.
Yes. Don't do it, no matter how tempted you may be. No.
No, I'm going to have to go real slow because, yeah, you know, sometimes you hit the wrong button.
That's fine. Yeah. And again, I'll try to, like, if you can't, you've got my Facebook Messenger, and I'll have it. So even if I have to turn the video off for a second, I'll hear the messenger go off, and you're welcome to message me if you've got a problem, and I'll make sure I will be around and tied to my phone. And like I said, most of the time you will be playing in the background because I want to take this class too. So.
Okay. Let's see if I. Oof, yeah, okay. Hopefully, I guess I won't be able to, if I stop sharing, if I need to rearrange slides, I guess I was, because some of the slides I might have to go. Okay, yeah, I think this will work.
Okay. As long as you don't hit stop sharing, I think you're fine. Like, you may even be able to.
Can we try it one time now, just in case I like accidentally hit it? If I hit
Sure.
stop sharing, let's see
ahead.
what it does.
Stop sharing. Okay, yeah, it completely removed it from my side. I can't even see it down here.
Okay, let's see. I'm also wondering if okay, so that little squiggle I drew is not there anymore, so that's cool. I'm just wondering if I mark up my slides a bunch, is it going to permanently like keep that marking thing on there?
No, I don't think so. Yeah, I think it's only like live during the presentation unless you save it.
Yeah. Okay.
So it looks like Vincent's going to be joining for part of it, but he said it's too late there, so he's going to watch part of the replay tomorrow. And I know we had some others come in, so that said that they were going to. And I had somebody order twice accidentally, and I had to get them refunded for one of those this morning.
Okay, cool. So I think so. Then I just go present again, and then then you'll have.
And then I'll probably have to add it to the stage.
Okay. Let's see.
I'm gonna have to fix that next time because there really should be a way for you to do that without me having to do it.
Share screen. Yeah, there probably is a way, but like I said, I'm usually the one that's in the
control seat.
Yeah, I've never been on the other side. I've seen other people do it, but yeah, it should be. I won't need to stop. I'm pretty familiar with the slides, so if I need to jump around, that's okay. I'll just not exit.
Now I think you can exit full screen and like go back to this screen, and select your slides again and go back to full screen. I don't think none of that's going to bother it as long as you don't hit stop sharing.
Yeah, like you can see all my slides now, right?
Yeah. Yep.
Okay, yeah, and then I can go to slideshow, and then it'll just. Yep, that should work.
All righty.
Cool.
Dude, I'm excited about it. Well,
so where are the other? The other thing is I can't see any of the other people, and I can't communicate with them. Like I was hoping.
They're going to communicate. Can you see the chat on the side?
Yeah.
That's the way most people will be communicating. We won't have any faces or anything.
Oh, okay.
Yeah. The next time we do this, my plan is to do. They StreamYard just came out with a new like class format. Yeah, and so I plan on adding that capability to it next time. So.
Oh yeah, but you probably got to pay for that one, right? Pay a lot more.
I think it's a separate module. So.
Oh yeah.
And StreamYard's already not the cheapest thing, as I'm sure you know.
Yeah. I just use the free version. It's cool. Yeah, I've seen people do a lot of this stuff on Zoom, but I haven't seen them doing like a class thing on StreamYard before. Yeah,
I think they're I like it this way because I took a couple of Zoom classes, and it was actually more of a bother having people talking, not turning their microphones off, and all that kind of stuff. And so most people, and then a lot of times, like you had international students who were communicating via chat anyways, because it was easier to use the translation software, for their via text. So that's kind of just the way we went with it. But, all right, I would expect people to be jumping in and out. We got 4 right now, but I know that there's like 6 or 7 that said that they're going to have to do it later.
Okay. Here's another interesting thing. It says join the chat on my end, and it says connect my YouTube account to join the live chat. My YouTube account don't have a YouTube account anymore.
Huh. That's all right. You shouldn't need the chat, I don't think.
Yeah. So okay.
It is odd that it won't let you just go ahead and just type into it, though.
Yeah, when you the YouTube, a lot of bad stuff happens when you lose your YouTube account because it's all connected to Google.
Oh yeah.
So all kinds of bad stuff. Oh, I think maybe it just worked. There we go. I think it's connected to my other. There we go. I'm in the chat now. Cool.
Okay, cool. Awesome. It should. The comments are supposed to be on there automatically.
I can see the comments. Yeah.
Okay, as long as you can see them, it's not a big deal. Like I see it, like whenever I pull them up manually. Like we got Alejo here, and Vincent. So, okay, cool. As long as everybody's working, we're good.
Yeah, I think we're good. So you can see my first slide now, right?
Yep, absolutely. Breeding for elite isolates with Mossy Creek mushrooms. Hey, that's me. Thank you.
I just want to make sure they can see everything. Yeah, I think you're right. This will probably be easier without all the Zoom meetings get a little bit chaotic.
They get super chaotic. So, all right. Sorry, go ahead.
Oh no, I was just gonna make you. I say, yeah, you always got some kid or there's somebody's talking to their kids in the background.
Oh yeah, well or chewing on chips. That was the last class. This one guy was kept eating chips with his microphone right here and would not mute himself, and it absolutely just ate it up. Like ate me up one side and down the other.
There was a beautiful presentation by Hamilton Morris, and it was just destroyed by one of those guys. It was so sad.
Yeah. Yeah, it'll do it. But all right, everybody, I give you to Ed. Ed, if you need anything, holler at me.
All right, cool.
All right, man. See.
All right, see you in a bit. Okay, you guys. Let's see. I don't know if oh man, yeah. So you guys can see me down there in the corner. I guess I don't need to make myself big, because I don't want to hit the wrong buttons. So if you guys don't know, my name's Ed. I don't really probably need to go into my background. I'm sure some of you know me already. The one thing I was hoping to get to do is to get to know you guys a little bit better, because I'm not really sure what y'all's skill level is. But I guess we'll just have to roll with that. So one thing I want to make very, very clear, you guys, if you have a question, I'll be watching the comments section over here. Like it's just right there. And so if you guys have a question, immediately stop me. I don't care if I'm in the middle of I don't care if I'm in like the middle of a sentence or whatever. There's a lot. This is a very, very information dense presentation that I put together here. This is actually kind of something I've been working on for quite a while, and it's going to be probably the basis for maybe some sort of book that I might write later. And so I've been trying to organize my thoughts. I think I did a fairly good job getting them organized. And some of you guys probably haven't seen a PowerPoint presentation for a long, long time, and they do tend to get a little bit boring. So I appreciate you guys stopping me at any point you don't understand maybe a term that I'm using, or any kind of concept, or anything basically. Or if you have any questions, or if you want to, maybe take a break. I reckon after about maybe an hour and a half, 2 hours, we'll take a break, because, I'll have to go to the bathroom also, and things like that. So I thought we had 6 hours, but I think it changed to 5. But you guys, I'm basically, it's like it's midnight here, a little past midnight, but I made sure I got up extra late today. So I'm ready to go, man. I can go till, 7, 8 in the morning if we want to. So that being said, I'm sure we'll be burned out after a little while, but, I won't. If you guys are familiar with me, you probably know that I can talk about mushrooms for hours and hours and even days. So yeah, I've been known to go on for 5 or 6 hours about some of these concepts. And so if we get off on a tangent, that's okay, because like I said, I don't really have much to do over the next day or so, or at least 12 hours. So if you guys have questions, like I said, please feel free to put them in the comment section, and I'll do my best to interpret them in text. And so, yeah, if any of you guys, like we said, might as well get started here. Make sure I press the right button. Again, I'm still I'm not super 100% familiar with Google Slides, to be honest, but and there we go. I'm already hovering over the stop sharing button because I need to, there. Okay, I'm looking for this. So there's the fancy title, as in, I didn't know what else. Sometimes people call them elite isolates. I imagine most of you guys are gourmet growers. As some of you probably know, I have, I've been growing mushrooms for, I guess I started when I was about 18. So what has it been about, about 34 years now? So, I started off with some of these original, multi-spore syringes, PF Tech, that kind of stuff. And then I slowly found more resources and I got more into the gourmets. I played around with the idea of starting a gourmet mushroom farm, and doing that type of stuff. And I'm sure a lot of you guys are probably in the midst of that right now. And so I imagine most of your expertise and your background and your goals for the future revolve around that type of thing. Again, you guys probably know I'm interested in all types of mushrooms. So if you have, species specific questions, I'm more than happy to answer those. There's this kind of like a no holds bar. You don't have to worry about I guess legal issues, if you want to call that, or things like that, because this is a private conversation, right? And nobody else is going to know these little secrets we have here. As most of you probably know, also I'm like fairly vocal about my advocacy for medicinal fungi, and so that's one of those things that feel free to ask questions about that. If you guys don't know already, I used to have a YouTube channel that was fairly specific in the Paniolus and the cubensis kind of breeding techniques and how to grow them and how to breed them. And so I developed a lot of these techniques based on things that were well known, and I just sort of refined some of them. And I also have a PhD in mycology, technically in botany. So one of the things I did for my PhD was to actually isolate a lot of monokaryon isolates, which, single basidiospore isolates, or SBIs as they're sometimes called, or SSIs, or just, haploid cultures, and breed them together. So one of the main purposes, I think, of this presentation is to teach you guys techniques on either how to isolate single spore and get haploid cultures, what we call monokaryons in the basidiomycete world, and to mate them together and to evaluate the results. And so some of the techniques, they're fairly straightforward, and they're not unknown. It's just, as you guys know, some of the literature and some of the techniques on the internet, they're kind of dispersed and scattered, and they're discussed in different forums and on different platforms. And so because I have a little bit of an experience in academia, and I'm fairly well versed in chemistry, and I also worked in like a medical research lab. I did some crazy stuff with radioactive isotopes and flow cytometry and, nuclear staining and things like that. I've kind of got this sort of broad breadth of knowledge from different types of sciences, different fields of sciences. I'm also quite interested in things like, permaculture and plant breeding and animal breeding and things like that. So I try to put all of these things together and apply it to mushroom farming. And so just earlier today, I was isolating, single basidiospore isolates. I don't know how well you guys are gonna be able to see that, but I've got three little spores that have turned into cultures on there. And I'm gonna take these and breed them with themselves, maybe, just to make sure that they breed with each other, and other single basidiospores, isolates or cultures, monokaryon cultures that I've isolated from other things, and also use diamond mating, which I'll get to here in a minute. Diamond means dikaryon monokaryon mating, and so that's a very, very powerful technique, especially if you already have a lot of dikaryon cultures, which I'm sure a lot of you do. When you get dikaryon cultures, of course, you can fruit them and then you can get the spores. That's another thing I want to focus on too, is that this whole methodology revolves around the use of spores. So one of the things I did want to ask you guys is if you have a microscope, and if you do you know how to use it? A lot of people have microscopes, but sometimes they've never used them. I know a lot of guys and girls who get scopes, and they pay $250, and then it sort of sits in the corner, and then they never use it. So if you have a microscope, that's quite helpful. There's a lot of ways to sort of get around it. Especially if you are fruiting a lot of mushroom cultures, you can evaluate their phenotypes. And it's kind of maybe irrelevant whether, in fact, you have isolated a novel isolate or a new isolate, or maybe you've just isolated a different cut or a different genotype. So that sometimes in the gourmet world, it's kind of irrelevant whether you've had them. Say you want to cross like what are the two, like a black pearl with a blue oyster or a Hungarian oyster or something like that, and you want to breed them together. Well, whether you've successfully bred them together or not, you're probably going to evaluate the success of that breeding or that mating with growing the mushroom and looking at the phenotype. So regardless of whether you've maybe accidentally rebred, two blue oyster mushrooms or two Hungarians together, instead of, crossing a Hungarian with a black pearl or whatever, it's kind of irrelevant because you've isolated a new strain. And if you like the phenotype and you like its look and its expression, then you can just run with that. In the kind of like more medicinal world, i.e. cubensis world, a lot of people are very, very competitive, I guess you could say, and they're very critical of each other when it comes to evaluating the success of a cross. And that's primarily because the maybe less than scientific ways people have traditionally done crosses. So I'll get back into that here in a minute. And what I mean by that is it's kind of like what the cannabis people would call pollen chucking, kind of where you just like mix a bunch of spores together in a variety of ways, and you just see if something takes, and you look to see, if you've got something that you like. And then you clone that, or you get that cut. You do a pheno hunt, essentially is what it's called in the plant world. So a lot of what we do in the gourmet world, as well as the medicinal world, involves simply maybe a simple thing like taking 2 swabs of 2 mushrooms or 2 spore prints and just sort of mixing them together. Or you take spores from one mushroom and you rub it on a petri dish, and then you turn it 90 degrees, and then you take spores of another mushroom and you rub it on there. Or you can do like a tic-tac-toe pattern, a little grid. That works just as well. The probability that you're going to get something that actually crosses with a different strain or a different isolate, a different type, is like 50-50 essentially, right? Because, well, depending on exactly how you do it, and there's various techniques. You can do serial dilutions also, but we'll get back into that in a second here. So let me real quick before I get into the slides, because when I go to the slide page, you guys, I can't actually see, I can't see your comments, and I'm horrified to start changing windows here. So Strand Farmer, yes. Let's see, both here. Super excited for this. Strand Farmer. I wish I could put you guys' things up on the screen. Gourmets and specials. Yeah, the techniques I'm going to talk about are equally applicable to both gourmets and specials. Doesn't matter if it's the Psilocybe cubensis, a Panaeolus, it could be an oyster mushroom, Ganoderma, whatever. These techniques are all applicable to any Basidiomycete mushroom, and with some modifications also ascomycetes. So some of you may be interested in cordyceps. I know Andrew has been growing some cordyceps. To get the single spores from cordyceps, I might as well just say it now before I forget. The trick to getting very good cordyceps strains is to isolate monokaryons and to remate them before you go into production. So some of the companies that have made their business based on the simple fact that they've isolated monokaryons, and when they find a good cross, it's kind of like F1, like hybrid corn in America, well, everywhere. You make hybrid corn, and the way they do the cordyceps, it's like you're making a hybrid culture, and that culture is going to show what we call heterosis or hybrid vigor. And so once you find that combination and you can remake it over and over again, you can essentially create a fresh new culture that has the full complement of genetics and can make cordyceps or make a mushroom or whatever. Cordyceps, for whatever reason, and a lot of the ascomycetes have this tendency for the strains to degrade. So you may get a mother culture, and then you expand it in liquid culture. You might make a liter or 2 liters, and then you run that maybe 3 or 4 or 5 times, and then you notice it starts to degrade. I don't want to use the word senescence. Senescence is probably not the right word in that case, but it basically gets old and maybe tired. Maybe it gets used to your substrate. Maybe just some enzymatic profile changes, and the productivity decreases. So what people do, or what those companies that sell the cultures do, they will sell you a fresh culture that has been kind of freshly mated. It's kind of like a newborn baby, it's full of energy and ready to grow and produce mushrooms. Whereas opposed, say a 50-year-old like myself, might not have quite as much energy and oomph left in them. And so they go back to those original monokaryon cultures. The benefits of isolating monokaryons, if you're really going to have a systematic breeding program, isolating monokaryons, which I'll tell you guys all about here in a few minutes, is really the key. One thing with isolating monokaryons is it does require a lot more work, and it can be labor and material intensive. So instead of, imagine having one of your, I got an MVP or whatever. I have, one dikaryon, I grow that, I subculture it, every time I make new spawn. But when you start isolating monokaryons, imagine, I've got 6 potential or putative monokaryons. So now I've got 3 on each plate, and then I'll have to check those to see if they're monokaryons with a microscope. And then I'll have a new plate for each one of those 6. I'll probably just pick 2 maybe. But so you end up with your original culture. Now you've got 2 new stacks of plates of the monokaryons. And then if you have, let's say, a GT or something, now you've got your original dikaryon GT, and now you've got your monokaryon plates. And then let's say you mix, your monokaryon 1 from GT with monokaryon 1 from your MVP. Now you got a new plate. And then if you do, this one with the 2 from the other one, now you got a new plate, and 1 and 2. And so the numbers just get ridiculous. So you end up with a lot of plates and a lot of stacks of plates. And that's where writing with a good Sharpie marker that's not going to rub off when you spray it with ethanol. Good old black Sharpies. For whatever reason, black Sharpies are the only brand of mushroom markers that I've found that will not rub off. They will rub off and they'll get faded, but they don't rub off as easily as a lot of the brands and even other colors of Sharpie markers. For if you're frustrated by things running or rubbing off your plates when you spray ethanol or isopropyl, IPA, whatever, black Sharpie markers are the key. So I don't know what's in the black ink or the solvent they use or whatever, but it works really, really well. So yes, Strand Farmer, we'll come back to the monokaryons repeatedly. That's me. I have a scope, but have not used it, Strand Farmer, yet. A lot of people have those scopes sitting in the corner that are maybe been opened, but not quite out of the box yet. Vincent also. Okay, there we go. Yeah, so it's pretty much the kind of one of those prerequisites when you say you want to get into mushroom breeding. The first thing people will say was like, you need to buy a scope. And then you go out, you buy your AM scope B120, or maybe go on eBay. I know guys that drop like $1,000 on scopes that they've maybe used a couple times. I know one guy who has like 4 microscopes that he's probably not used more than about 20 times each. But yeah, that's the way it goes. You'll use it someday. It's one of those things, like it's a thought that counts, like, yeah, I'll get to that eventually. I've got a $600 mountain bike that I bought a couple weeks ago, and it's been sitting in my kitchen, and it's still sitting in my kitchen, but I'll get around to riding it eventually. It's been raining a lot, so I don't know. So yeah, this is going to be a little weird too, me sitting here talking to myself, you guys. I thought I was going to get to interact with y'all a little bit better, but y'all should see the first so I used to live in East Tennessee. I used to live in Knoxville, so occasionally there's a couple things about the way I talk. Yes, I'm from Michigan, so when I say you guys, that's a gender neutral thing. I mean everybody, if there is any females or others, whatever out there, you guys means everybody. And also I do tend to say y'all sometimes, which is thanks to my 4 years in Knoxville, Tennessee. And sometimes my English isn't so good because I've lived here in Thailand for 22 years. So that's kind of starting to degrade my English skills also. So yep, there you go. If you guys need to contact me after the workshop, or what are we calling it? Seminar, workshop. I don't know. A lot of Americans use WhatsApp. I know some people here use it. I don't tend to use it that much, but I do. It is on my phone, and if you send me a message, it'll pop up. The line. I don't know if you can read it there on the far left. There is a that's basically the app that they use here. So and also then there's just email. So yeah, anytime you guys can contact me. And I just realized, you know what I can do? I can probably join from my phone. And just to make sure you guys are seeing the slides that I'm seeing. So let me do that real quick here. Like I said before, God, I just got to remember where Andrew sent me the link. It was on email. So yeah, I'm more than happy to talk about this afterwards, you guys. If you haven't figured it out quite yet, I'm quite passionate about mushrooms. The other thing, I think I set my microphone up in a good place, and it's at a good distance from my mouth, so that should be good. Like I said, we got 5 or 6 hours here, so no big hurry. And I was going to ask you guys what you were familiar with, but I think we sort of did that already. Let's see, you guys here. I need to enter as a guest. Yes. And I need to... Okay, you guys. I'm going to put my phone really far away. Okay. Okay, you guys. I put my phone way out in the other room, so hopefully we won't get getting any reverb. I may have to. I just want to make sure that you guys are seeing what I'm seeing. So yeah, there's a lot of resources on the internet. Basically, this is a slide. I was gonna expand on this a little bit. Yeah, you guys. I'll turn off my. Yeah, how is that? Is it going to be okay? Yeah, sorry guys, I might have to just totally turn off my phone. Is it still echoing? Yeah, that was one of the things about I thought maybe I could use my phone to maybe take you guys on a little tour of my lab, but I don't think that's going to be able to happen. Yeah, I tried mute. It's weird. Yeah, it's weird. You can't totally mute the phone when you're using StreamYard for some reason. I don't know why. Okay, guys, is that okay? Yeah, for some reason it doesn't. I don't know why on StreamYard it doesn't let you mute on the phone. It won't let you mute the phone. I don't know. There must be some reason for that. But let me know if it's bad, you guys, and I'll just turn off my phone. Is that okay? Yeah, I would love to be able to. Let me see if I can pull this window down here so that I can see. Yeah, there we go. So is that yes, you guys? Yes, it's better than before? Or yes, you can still hear. Okay, yeah, let me just go turn off the echo. Okay, yeah, sorry, the technical difficulties here. So let me just get into the meat and potatoes of it here, you guys. Get on the right slide. There are lots and lots and lots of resources. I'm sure some of you are familiar with, obviously there's YouTube videos. There's a surprising, I don't know if you're aware, there's been this kind of ongoing war against mushroom people on social media. Facebook, Instagram, people have been kicked off Patreon. It just goes on and on. If you know anybody who's into the social media, they probably have at least one story about being kicked off one of the platforms. So it's really, really frustrating, but unfortunately, that's just something that's going on. If you're a conspiracy theorist, you could probably get into why that was happening, talk about big pharma and stuff like that. But yeah, it's whatever, it's happening. We can't do anything about it. So one of the things I wanted to ask you guys, I think I can guess already, so we don't really need to go through this. What species do you want to grow? I'm assuming most of you guys are oyster mushrooms or maybe maitake mushroom growers. I don't know, some other people. Here they have the what are called milky mushrooms. That's one of the ones that is really, really quite fascinating. That's starting to get really big over here. It's called Calasabi indica. I don't know if you guys are familiar with this one. It's something, if you are a mushroom farmer, you might want to start looking into. It's one of those that's getting quite popular here. And let's see, here we go. Yeah, and I have cultures of it, and it's quite readily available here. Unfortunately, I can't sell or send stuff to the US anymore because of the problems with tariffs and all that crap. But yeah, that's one of the up and coming ones here. Of course, you got things like maitake, the Grifola and Hericium, and good old oyster mushrooms. I don't reckon anybody's like an agaricus farmer out there. But cool. Let's see. I want to go to them all. I'm going to try to go on. So, oh yeah, you're talking about the Calasabi. Yeah, I'm not sure exactly how it's grown differently here. I could look into it, but let's talk about monocaryons that apply and breeding that applies to all of these things. I'm assuming some of you guys have poured agar plates. If you're going to breed mushrooms, there are ways. Again, if you're familiar with the old school like brown rice flower tech or PF tech or spore syringes, that technically doesn't require any agar plates. And I'll come back to that here in a minute. But it's really, really helpful if you are going to breed mushrooms systematically to be able to pour your own agar plates and be able to do, sterile tissue culture work. Again, not 100% necessary. In fact, a lot of good breeding has been done probably without the use of any agar plates or auger plates, however you want to say it. And that's probably where the majority of the strains that we've grown and everybody else has grown probably come from, just simply somebody doing a multi-spore syringe or maybe taking a spore print and just suspending it in water and inoculating. I don't know. It might have been even, sterilized cardboard or soaked cardboard. There's a lot of species that will just, spores will grow on cardboard, or even wood chips, pasteurized, sterilized, fermented wood chips. As you all know, that's really not the most efficient way to go about it, and very, very problematic. And it's probably not been successful most of the times, but it could. In very rare occasions, it could probably work, but I wouldn't suggest it. So a lot of the things I'll talk about here are pretty much, they revolve around the use of agar plates and your ability to do sterile tissue culture work. So that's why I was going to ask you also, if you guys have an FFU, which is a fan flow unit, or you have a still air box. Again, if you haven't learned how to pour agar plates and you plan on continuing to grow mushrooms and breed mushrooms in particular, you will definitely want to, utilize sterile tissue culture. So tissue culture is more generically, if you can grow things like mammalian cells and bacteria and yeast. I had a lot of experience growing mammalian cells before I ever went back to school for mycology. And of course, I had my, amateur days where I was growing a lot of, things in my bedroom and, monotubs and things like that, where I utilized agar plates that I may or may not have borrowed from from my classes at the university. They might have fell in my backpack as I was leaving the bag, and I used those to grow spores that I got from the back of a magazine, and then use them to grow mushrooms. So that's one of the kind of key things. Let's see, can pour grab a microbabby. Okay, cool. I pour 10 of place with you, and I have microphone. Okay, cool. So some of you guys know how to do this stuff, and are familiar with it. Again, if you're not familiar with some of the words I use in particular, there's a lot of terminology, and you guys got to remember, this is the kind of stuff that goes through my brain every day. I probably read, on average, not every day, but probably 1 to 3 papers about either breeding or something about mushroom genetics or something about microbiology, or some kind of cloning that they've done. I try to keep, abreast of some of these current discussions and topics and, innovations that are being made. But it's almost too much these days, and you throw in the whole, when you type a simple question into some AI, and it's just, you generate 10 new questions, and you're like, oh, wow, I'm never going to catch up. But that's what's great about, this whole hobby. A lot of people, I think they get to a point where they sort of stagnate in the hobby because it seems like you're more of a farmer than a scientist. So that's probably one of the reasons some of you are in here, is because you want to reinvigorate yourself, and you want to make it's probably the coolest thing that you can do with mushrooms is you can create something completely novel that has literally never existed in the world. And then you can name it if you want. A lot of people have this, this overwhelming urge to name things. And so that I know a lot of people actually come up with names before they ever cross 2 mushrooms together. So maybe it's a black pearl with a Hungarian, oyster, and they want to call it like a black Hungarian or something, something funny, or, Astro Glider 4000 or whatever, something from a video game or something that they play. So yeah, it becomes a bit of like Strand Farmer saying, it becomes a bit of an obsession. So I'm warning you now, once you start getting into this, you can start to get in really, really deep. And you can basically turn your whole house into what looks like half meth lab, half mushroom farm, half something that you don't want your neighbors asking questions about. So it gets pretty deep, pretty quick. From Argentina, cool. Alejo Batana. Okay, so let's me meandering off here. You guys get distracted quite frequently. That's how I ended up doing those like 6-hour live streams I used to do on live tube. I tend to go off on tangents. So fundamentals of mushroom breeding, the compatibility systems, that's probably a little bit beyond what we need to talk about today. As some of you know, you probably heard the words things like homothallic and heterothallic and bipolar and tetrapolar. Those terms are not necessary for what we're going to do today. That's kind of, more like homework. Like if you want to know the difference between, say, a bipolar and a tetrapolar mating system, there's plenty of that information out on the internet. It's not really necessary for today's topics. Mating concepts, we're just going to talk about essentially what happens when you put 2 haploid things together. And one other kind of caveat kind of thing where we put like a dikaryon, which is 2 nuclei. It's basically, we don't call it a diploid. I'll get to this later. You can mix like a dikaryon with a monokaryon. So that's another way we can breed things. That's something called the Buller phenomenon, which you may have heard of. It's named after a guy named Buller. Most people probably just call it a dimon or a dikaryon monokaryon breeding. Phenotype selection, as I mentioned already, you guys are probably well familiar with this because you're mushroom farmers. One thing that's really, really super important that a lot of people tend to underestimate is the effect of the environment. This say, for instance, if you get a culture and you give it to your friend and you give it to another person, in another country or in a different environment, they may have a very, very different phenotypic expression. So the look, right? When you put these things into different environmental conditions, they're going to have very, very different expressions, different looks. And so you can have the same exact genotype, the same culture. And I have been seeing this. I moved from Bangkok up north. I'm about 10 hours north of where I used to live. And some of the things that I'm growing now that I've grown dozens of times down in Bangkok, they look very, very different here. And I've had to modify my tent. I grow in a 5x5 tent. Just today I got a humidification system. And so I'm really working to tweak that, because up here it's different temperature, different cycle every day. I don't know if you'd want to say daylight, but maybe the RH and the temperature, and maybe even some people say the atmospheric pressure fluctuations significantly affect how your culture is going to express itself. And I'm sure you all have seen that, in your grows, say just the yearly fluctuation. If you're growing the same thing, it may look very different in the spring and summer and fall, under what you think are basically the same growing conditions. But again, there's little subtleties that we may not notice. And so that's one of the things people need to be aware of. I know as a former vendor, when you send out cultures to people, they often, one of their biggest complaints is it doesn't look like the picture, and that's because maybe they're a new grower and they don't know how to grow mushrooms very well yet. So they get, they're expecting something that may be 6 or 7 inches high, and they get something that's 2 inches, and maybe they don't get as big of a fruit, or it looks differently from what they were expecting, and they get all disappointed, and then you have to very cautiously and gently explain to them that, this is the second time you've grown mushrooms. Maybe you're not doing it the best way. And then you gotta, if you want them to buy stuff from you again, you have to be kind of gentle about it. So yeah, that's one big thing that we'll talk about later. Also, so when you're selecting for a phenotype, let's say you're doing a pheno hunt, you need to make sure that your selection pressure, in the sense that if you have a culture and you're doing a pheno hunt, let's say you have one generation and you clone something and then you grow that again, you would expect it to look the same as the last generation. But if you've changed your substrate, or you've changed your concentration, of soy hulls or wheat bran, or maybe you've put new ingredients in, or something as subtle as if you're growing cubensis, you've changed the manufacturer of the coir or the vermiculite, or the size of the vermiculite. Or maybe, you move to a new place and you've got a different water supply. All of these things you need to take these in consideration. So when you are actually trying to consistently produce fruit, which is probably the goal of most gourmet farmers, you're trying to consistently make fruit, and as much as you can, that look like something the customer wants to buy. You've got to take all these kind of things into consideration. When you get into breeding, you also have to remember in the back of your head, right, that phenotype, or that pheno that you're looking for, is going to look differently if you start doing things like changing the substrate. Andrew talks a lot about this, how he has in the past, where you're sort of training a mushroom. You're turning on certain enzymes, and maybe you're down regulating or turning off other ones based on maybe your liquid culture media. Do you put maybe a little bit of wood chips in your liquid culture? Well, if you're doing that, and then your substrate, that you're going to grow the mushrooms on has, it's based on the wood chips that you used in your liquid culture, that's probably going to help the fungi be pre-adapted, sort of trained to that substrate. So those enzymes and all those different genetic elements inside, it could be mitochondria and other things that we might talk about later. These kind of things can change. They can get turned on, turned off. If you start getting into the really deep molecular biology stuff, you can start talking about things like methylation and, down regulation and epigenetic elements and transposons and copy number and mitochondria and all these. Like, things get really, really deep really quick. And Vincent mentioned that I'm not sure how to say it, Nieuwenhuis book. That book is really, really super deep. That is probably, if you really are interested in breeding. I also did the same thing. I fed it into the notebook I think it's an 85 page. I think it's actually his supposed to be his dissertation, his PhD dissertation. In Europe, they do the way they do dissertations slightly differently than the US. He essentially wrote a book, and that reference that I had in there, that's a brilliant book. And he has published some papers. The papers he's published are actually a little more, I guess, focused because they're shorter and they're more, they're more suitable for publication in a journal. But that book easily is the best book if you really, really want to get your brain going. In fact, there's a slide later on that has one of the diagrams from his book in the presentation. The other thing, you guys, I will share this presentation later with Andrew. I could do it now if anybody wants it now. I can go and I could probably share it, but again, I don't want to stop the sharing, so that would require me probably. I'll do that later. If you guys want a copy of this presentation, you can just send me an email later, and I'll send you the link on my Google thing, and I can share it with you. So 157 pages. Oh yeah, okay. I haven't actually. I've been meaning to go through that book in much more detail, but it's open. One of the windows. I don't know if you guys can see it, but it's actually one of the windows open on my computer right now. So it's funny. It keeps going back to the first page. I've been reading through parts of it, and then every time I open that window, it keeps going back to the very top, and then I lose my place. And finally, the practical laboratory stuff. I probably don't need to tell you guys about that. I've mentioned already how your plates are going to multiply dramatically. And so if you haven't already, find a cheap source for disposable Petri dishes. The polystyrene ones, they are fairly cheap here. Thank goodness. I think they only cost about, about 10 cents a piece here. But yeah, you'll definitely want to find a source of cheap polystyrene disposable plates. The glass plates, I don't really like glass plates. I constantly am breaking glassware. I don't know why they just don't make good glassware anymore. So yeah, it's difficult. It's just one of those things, We're using plastic bags, we're using plastic plates, whatever. I see people go through, 10 water bottles a day and chuck them in the bin. So I don't know. There's worse things going on in the world than us using our mushroom bags and plates. Another thing I wanted to be really, I don't know, again, kind of like, you need to be, what do they say, fastidious about record keeping. You need to, I write on the top of my plates. In fact, this one's pretty, the generic kind of, the strain, monos, and the date. Sometimes, you might want to write the F number, the filial generation. You might want the transfer number, T3, T4. Sometimes if it's a clone, you might want to put like C1 or C2. Different people have different designations. As long as you know what it means, that's okay. Sometimes when you see other people's plates, you'll be like, what the heck does that mean? Some people keep track of the generation. So you'll see a G, it might be like your G1, your G2, your G3, things like that. So whatever suits your purpose and your goals and your brain is fine. But I would suggest you get a good system and be consistent about it. Sharing plates with other people. In the past, I know sometimes I get spore swabs or plates or anything that it might be, you're trading and sharing or buying, and you get these things and it's like some cryptic, you need like an Enigma machine to like figure out what the hell these designations on the swabs are. And another thing, maybe try to, can use Sharpies and not like, I don't know, a ballpoint pen or something like that. Anyway, like you guys probably, you want to be efficient, right? So speaking of efficiency, let's get down a few slides here and let me get into the meat and potatoes of this. If we do have time at the end, I would maybe talk about the future application of fungal genetics. That is actually something that I am immensely and I guess intricately involved in on a daily basis in one way or another, and trying to make new medicinal compounds and make them better for people and in the future of humanity. So anywho, so the basics, you guys know the basic idea here. We're going to select a strain, so your species and your strain. prepare your substrate. And I wasn't sure, there might be some people out there who or maybe will see this later, that are, not familiar with how the process of mushroom cultivation, goes from start to finish. But, your strain selection, your substrate prep, some people might, choose grains, some manure-based substrate, wood chips, straw. There's just a plethora of different substrates. Usually the cheapest, most readily available thing is what you're going to go with. Or the one that's most convenient. Like for me, I grow inside, so I've got, CV, coir, and vermiculite. That's my typical substrate, even though substrate, not a really appropriate word because the mushrooms don't really eat the substrate. But if you're using something like wood chips and soy hulls or something like that, master's mix, your mushrooms are actually going to eat. They're going to eat that substrate. So inoculation, of course, you need to take that substrate, and then you need to usually sterilize it in some way. It could be atmospheric, could be a pressure cooker, could be some giant autoclave, especially if you're using substrates that are rich in nitrogen. I actually just found this out the hard way yesterday. I decided I was going to throw a little bit of sawdust in with my CV, my coir and vermiculite mix, and today I threw away about 4 shoeboxes because they were growing some kind of funky mold. It was because the sawdust that I have, it's kind of fresh and it's still got like way too much sugar in it. And so when I put that sugar into my CV, that's just asking for contamination. And I'm essentially trying to get rid of this big bag of sawdust that I have. And because that sawdust was pretty fresh, wasn't aged very well, I reckon it has a lot of sap and sugar left in it. And so that was, that was just like asking for trouble. And I threw away a bunch of trays today that had some funky like mold that I didn't want to wait to find out what it was. It almost looked like Neurospora, which is a particularly insidious kind of mold. If you get it, something's going wrong, and you definitely need to figure out what's going wrong real quick, because it can just wreak havoc on a mushroom farm and cultures. It's kind of one of those things that'll like crawl out of the petri dish and like infect other petri dishes like an inch away from it. It's just horrible. Anyway, we may talk about that a little bit later. Incubation, we probably don't need to talk about that. Initiation, fruiting, and then your harvest. So again, you guys don't need to probably hear that again. So here's the basic idea. I'm gonna let you look at this for a second here while I take a drink, because this in one slide pretty much summarizes the entirety of all the breeding methods I know that have been discussed in the last 40 years or 50 years in the books, the forums, Reddit, web pages, the Shroomery, Mycotopia, whatever, Arrowid, the Stamets books, the Pollock books, the McKenna Brothers books. This is pretty much it. So I'm going to try to talk about these in a little bit of detail. And if you guys want me to go into one or multiple or all of them, I can go into a lot more detail. But essentially, they all rely on the same exact thing. And that's that we're trying to take 2 haploid spores and we're trying to mix them together, and we're going to get a new complete organism. And then we're going to fruit that organism, and we're going to see what it looks like. And if we like it, we'll clone it and maybe even get some spores. And if we don't like it, we might do the same procedure again and try again. And yep, that's what it is. It's pretty much an iterative process where you start with spores and you mix them together and then you see if you like it. And if you do, you keep it. If you don't, you do it again. So it's a numbers game. Here is another thing I should probably emphasize. So when I first got into, so I've been in and out of the mushroom cultivation world on and off for like 35 years. I've always been interested in mushrooms, but I've been in and out of the mushroom breeding and growing world for probably, the last 35 years. And so I'm 52, if you guys. So the first time I ever grew, mushrooms in my closet, cubensis was, I think I was 19 or 20, and multi-spore syringes. And so what is that? 33 years. And I didn't know what I was doing. I didn't have a clue. And so again, on and off over the years, I dabbled in this and that, and, life got in the way, had a job, taught at a university, yada, yada, yada. And then about 6 years ago, I went online and I saw all of these albino mushrooms. And I'm like, what the hell is an albino cubensis? You see something like a tat, a true albino teacher, or an albino stargazer, and you're like, what the hell is that? Like, I know a stargazer. A stargazer is the strain of mushrooms that Paul Stamets, tripped on. He's got a whole story about this, and it supposedly fixed his stuttering problem. And the next day he went and talked to some girl. Yeah. He's got a whole story about that. So I'm like, what the hell is an albino stargazer? In theory, obviously I know what an albino is. We've got albino squirrels around here. I've seen albino deer and albino fox. But I'm like, what the heck's an albino stargazer? So this was obviously very fascinating to me, that you could have an albino mushroom. And I've never seen an albino mushroom ever in the wild or in a picture. And I'm seeing these albino things and I'm like, how did they get an albino mushroom? Is that some sort of sorcery or some kind of magic? Did they use some kind of mutation method, or did they do some genetic engineering? No, it turns out it's a numbers game, you guys. You literally, I can guarantee 100%, if you cross two mushrooms together in the way that I'm going to explain, you take their spores and you mix them together. And if you take that mushroom to its F2, which I'll explain what that means, the second filial generation, I can guarantee with 100% certainty, if you do at least 100 plates, you will find an albino mushroom. If you want to make an albino stropharia, rugosa annulata, or you want to make so they've got albino cordyceps now, right? And this is because it's a numbers game. When you breed enough mushrooms and you go back to spore consistently over and over and over again, albinos just pop out. It's purely a numbers game. And because we have the ability to clone mushrooms and isolate them and continue to grow that genotype, phenotype, whatever you want to call it, you can have this consistent line of albino mushrooms. In these days, every mushroom, if you've got a GT, true albino teacher, it's an albino GT. We got Louis Vuitton, then you get an albino Louis Vuitton, you get a stargazer, you got an albino stargazer. And so this, sometimes they revert and then they go back to being normal colored. You could talk about the, ecology and whatever the evolutionary sort of reasons for that, and all the population genetics and things like that. But we don't need to go there. So I guarantee that if you're looking for an albino, if you've got a GT spore print, and if you go back to spores enough times, you will find an albino GT. It is just, it's basically inevitable. So that's because we go back to spores. And as you guys probably know, maybe from 9th grade biology, when you go back to spores, it's kind of like why you and your brother and your sister, well, obviously your sister, you're going to look different, but say you have 4 siblings, and you say you got 3 brothers, they all look different, right? Even though you've had the same 2 parents. Now, you probably don't have an albino brother, but if your parents had enough babies and enough of your dad's sperm mixed with enough of your mom's eggs, you would get an albino brother. It's just inevitable. It's a numbers game. So albinism and a lot of other traits that we're interested in, weird things generally, they're what we call recessive. They're recessive alleles. So there's another word that hopefully doesn't scare you guys. We have this thing called dominant and recessive, and those characteristics, they describe what we call alleles. So we can have like 2 versions in the very simplest example. We can have 2 versions of every allele. So let's say you got an allele for color, and in the very simple, kind of scenario, you've got a brown allele and a white allele. And so the brown one normally covers up the white allele, because that makes sense, because, you mix brown and white together, it's going to be brown. But in reality, what it is on a genetic level, those brown alleles are what we call dominant. And so if you have a mixture of, say, you get a brown one from mommy and a white one from daddy, it doesn't matter. It's still going to be brown, because the brown one is dominant. It means it literally like covers up the white one. right? And so that's where we get these terms dominant and recessive. And the other side of that coin is that if it's a recessive allele, what's going to happen is you're going to have to get a recessive allele, say the white allele for albinism or whatever. You're going to have to get a white one from mommy and a white one from daddy. And the only time it's going to show itself is when both mommy and daddy's contributions are the white allele. So that's how we get albinos. So you think like, wow, that's probably not going to happen very often. But in fact, it happens way more often than you think, because these albino alleles are hiding out there in nature. And you're just basically, it's a numbers game. Again, I'll show you this thing called a Punnett square later. It basically shows you how to roughly calculate the percentages of the offspring. What their genotype is going to be, i.e. whether they're going to be white or white brown or brown brown. It'll show you the percentages, basically it's probability, and it'll also show you what the phenotypes or the outward expression of those alleles will be. So that's essentially what we call Mendelian genetics. That's the basis for most of the things that we're interested in. There's other things that are way more complicated, like blood types and hair color and height and intelligence. Those are multi-allelic. We've got other things to deal with, things like pleiotropy and all these fancy genetic words that we don't need to know right now. But if you're looking for, say, a new type of mushroom, something that's very, very different, there's a good chance that difference is going to be one of those recessive alleles. And so again, the numbers game, you just keep doing this over and over and over again, and you will eventually find one of those weird kind of mushrooms that you might want to isolate and further propagate. And so that's what we do. That's what we do. That's the whole name of the game. So real briefly, let me go through these guys before I get into super duper detail about any of them. You might be familiar with the grab and drag. So the first one here, this in one way or another has kind of been contributed to me. I modified a technique which is called streaking. You can see down there. There's some subtleties. I'm not saying I made it up or anything. I just sort of did streaking in a slightly different way. I can show you it's actually right here. This thing that's called a grab and drag, where essentially you take some spores and you just do a little serpent. I don't know if you guys can see that, but you do sort of this little serpentine pattern. And I can go into that in more detail later. But it's a way for you to get single spores. So you get these single haploid spores, like I did here, and then you can isolate those, and then you can mate them with other single spores. Or single, what we call monokaryons. So that's called the grab and drag. Again, I used to have a bunch of videos about this. Those have subsequently been taken off YouTube. They canceled my channel. At least that worked when we were doing that. At least I can comment. My YouTube channel got taken down, I think it was about 1.5 years ago now, something like that. Can't really remember. But yeah, one day I just woke up and they were like, your content is harmful and dangerous. So bye-bye. Anywho. Streaking and double swabbing, that's another technique I can go into in more detail. I'll ask you guys, like if you have a question about one of these, like tell me as we're going along, because if I kind of went into all of these in detail, we might be here for about 12 hours. Another thing you may be familiar with is this MSS. MS stands for multi-spore syringe. So multi-spore syringe is and was a very, I guess you could say, technically legal way to distribute mushroom genetics in the past, and still is. It gets around the fact that spores, especially of the psilocybin variety, they don't have any psilocybin in them. Cultures, regardless of what anybody says, a live culture of, say, Psilocybe cubensis does have alkaloids in it. It's such a low quantity that it's like undetectable. But if you've ever grown that type of mycelium and you see it turn blue, that's an indication that there's alkaloids in it. So anybody who's selling this, what we call liquid culture now, who says there's no alkaloids in that culture is kind of cheek and tongue. No alkaloids. But they're in such a low level that they would not be detectable by any modern technique that the authorities would use. So the way of getting around that and the legalese around that was spores do not have any alkaloids in them. Maybe if you had like a kilo of spores, you might be able to extract something out of it, but I don't think so. So anyway, a lot of states, spores are 100% legal. That was what I used to do. My business was essentially sending spores to people in all kinds of countries and all over the world. And it's technically legal because there's no alkaloids in those spores. So that's that kind of technique is not really very common with gourmets. I know it has been used by some people. The main reason you would use that type of technique is essentially you take a spore print and you suspend them in sterile water. And so the idea is there, when you suspend them in sterile water, you're going to have the spores kind of break apart. And so you'll have single spores. And then so you use those spores, and the technique used to be called the PF tech. It's named after Psilocybe fanaticus, or now we call it the brown rice flour tech, where essentially you take these cakes it's vermiculite that's been coated with brown rice flour, and you sterilize them in these half-pint mason jars. And you can look it up on the internet. There's plenty of videos about it. And then you take these syringes that have your spores, these MSS, these multi-spore syringes. And as the name implies, multi-spore, there's a lot of spores floating around in there. And so you can shoot them into this cake and they'll germinate and you can grow mushrooms. Here's the cool thing about that is every time you do that, you're creating new strains. So as I was saying, if you're looking for an albino, you could potentially have two spores that have that recessive trait come together and make the complete organism, the dikaryon, and make an albino mushroom. 99% of the time, you're probably going to get a bunch of brown mushrooms, but that's usually what people want. The other cool thing you can do about that is you can take syringes of two different types of mushrooms. So this is a way that some people used to do in the past. You're mixing the spores of two different mushrooms. So now you're back to a numbers game. Again, you could have like the spore from the mushroom 1 and the spore from mushroom 2, and now you successfully mated those two mushrooms together. But that's again, not really probably the best kind of way to do it. You could do that with oyster mushrooms. But anyway, that was one of the main ways that people grew cubensis and stuff in the past. That was because the spores were legal, and you could order out of the back of some magazine. You could order 3 syringes for $20, and you're off to the races. As long as you had a pressure cooker or even brown rice on vermiculite, you could sort of steam the substrate, and that was usually enough for the spores, assuming they weren't too contaminated to basically germinate and grow, and you could produce mushrooms. And then you could use those cakes for other things, which is kind of neat. So that's kind of what I'm talking about there, the multi-spore and the multi-spore. That's one of the ways you can basically breed mushroom without really having to do too much fancy stuff. Another way, so people got around, got a little more sophisticated, and they started using a mono. So here where it says mono, that means a monokaryon. Let me get my little pen here. Let me change the color of the pen. I just happen to have it red, which probably isn't the best color right now. Let me use green. So this here where I say mono, this means monokaryon. So one of the neat things you can do if you get good at making grain spawn is you can at some point maybe get a mono from a friend. Or maybe you can buy one, or maybe you can isolate your own, and then you can mix that mono with a multi-spore syringe. And so you have different ways of doing that. You can grow grain spawn that is monokaryotic grain spawn, and then you can shoot your multi-spore syringe in there. That's probably the better way to do it. The other way would be maybe shoot 2 liquid cultures in at the same time. There's different ways, and I don't know. I could go through the attributes of each one, but that's probably not necessary. But this is when you can see people are getting a little more sophisticated, right? Instead of just shooting multi-spore syringes into brown rice flour cakes, they're starting to mix 2 together. Then they're like, hey, somebody's like, hey, I got this mono. Let me try and mix that with another strain that I've got this multi-spore syringe for, and see what happens. Well, then you're really starting to get into some breeding stuff then. So let me look at the comments here real quick. Yeah, YouTube can be hard to navigate. Keeps your channel. Yeah. Yeah, YouTube's a pain in the butt. I thought about restarting another channel, but I'm not sure I'm up for it. That heartache. How to differentiate mono and dicarian, any visual difference? Yeah, so Neith, I'll just call you Neith here. Neith, this is unfortunate, and there's a lot of sort of folklore revolves around this kind of idea that you can look at a culture and tell whether it's a dicarian or a monocaryon. So in cubensis were a very good pick, or kind of volunteered themselves to the fairly straightforward mushroom cultivation techniques that were around 40 years ago, because they have rhizomorphic growth in a dicarion. So one of the neat things, if you see a cubensis culture and it's a dicarion, if you have it on the right media, I have some right here that have been grown on gel and gum that are tomentose. So this is not a good representation. You guys aren't gonna be able to see this very well, but the cool thing about cubensis, if you have a dicarion, it will be rhizomorphic on the right type of media, generally MEA, malt extract agar. If it's on different media, it will not necessarily be rhizomorphic. And also, if it's not grown at a temperature that's suitable for that rhizomorphic growth. If you get to other species of like oyster mushrooms or any other kind of non-cubensis mushroom, you can't really just tell by looking at it. A lot of people, and again, this has gone on and on for decades, people will argue till they are purple in the face about how a monocaryon should look like this, and it should have this radial growth, and this and that, and it's all untrue. I've grown thousands of plates of monocaryons, of lentinus, of polyporus, of cubensis, of pleurotus. There is no way you can look at a plate and just tell whether it's a monocaryon or a dicarion. I hate to burst people's bubble. Those people who are telling you that kind of stuff are generally not very experienced in using a microscope. And so a lot of times what they think they're dealing with a monocaryon, and a lot of times they're dealing with dicaryons that are just tomentose because they're not growing on the right media at the right temperature. I don't want to get into it any further. It's a very, very contentious topic. And the people, especially in the online cubensis world, will tell you they can tell what a monocaryon looks like. I mean, it doesn't take more than 5 minutes into a discussion about breeding, and somebody will assert, that they can tell that that's a monocaryon because it looks like this. And I can guarantee they're wrong. Again, I've gotten very heated debates about this with people over the years, and I just stopped talking about it with them because they're generally people who they want to sell stuff, and they also don't want to use a microscope, or they don't know how, or they don't have a microscope, and so they would like other people to believe that a microscope is unnecessary. In fact, there's 3 people ringing their voices are ringing in my head right now who constantly say, you don't need a microscope to breed mushrooms. That is true. That is true. I went through at least 2 or 3 different ways that you can breed mushrooms without a microscope. But if you are going to isolate monocaryons and be 100% certain that what you're using to breed in your systematic mushroom breeding program is a monocaryon, I'm sorry, but you're going to need a microscope. That being said, I mean, it depends how comfortable you are with uncertainty, I don't know. Some people ride a motorcycle without a helmet. Some people don't wear their seatbelts. Some people buy white powders from China in a bag and put them in their body. I don't know. I'm not really up for any of that stuff, but yeah, some people do. Anyway, so yep. Yep. As Nee said there, finding clamp connections, or rather lack of clamp connections. So that's the unfortunate problem with working with monokaryons is you're not looking for a clamp connection. A clamp connection is actually fairly easy to find. What you're looking for is the absence of something. And so that's the problem, because how long do you need to look before you're certain that something's not there? You know, it would be like if you went to a stadium of 100,000 people and you're looking for a guy named Bob, and you go through the stadium and you ask every person, is your name Bob? Is your name Bob? Is your name Bob? Is your name Bob? Like, how many people are you going to have to go through before you can, you know, with 100% certainty say, well, Bob's not in that stadium because I didn't find anybody that said their name was Bob. Well, that doesn't mean Bob's not in the stadium. So at a certain point, let's say, you know, 674 people, 1,000, whatever, you know, like you got to kind of make your mind up and be like, well, maybe Bob's not here. Anywho, we can come back to that later. I forgot some slides down the thing. I forget, you guys haven't actually seen any of these slides. I have pictures of this stuff later on down. Germination plates, that's essentially where you essentially take. So what I did earlier, you guys, I made what's called a streak plate. And then I took that streak plate and so it's MS. So you notice I have this labeled MVP, blah, 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 MS. That means multi-spore. So what I did is I essentially took my spores and I just swabbed them all over the plate. You can do it with, you know, your scalpel, a cooled off scalpel. I use sterile cotton buds, and I just took my spore print and I grabbed some spores and I just rubbed them. I just painted them on there. And so I got a bunch of germination points there. And then I just took that big old square and I made spawn out of that. So what I'm going to do is fruit that spawn, and all of those dicaryons, hopefully at least, you know, 5 or 6 of them will grow, and they'll show me the type of mushroom they produce. And when I see those mushrooms that I want, or maybe don't want, I can clone them and then I can grow them again. So that's kind of maybe like a sort of ghetto way of doing breeding from a swab plate. You just kind of grow the stuff that you swabbed and look for something you like. And if you find it, you clone it. So that brings me to a second way, what's called double swabbing. It's actually on I missed it up here. So double swabbing is, sometimes people call it ghetto swabbing. What you can do is you can either take, so here, I think I can draw on this. So double swabbing is where let's say your Petri dish. I actually have here, I have a stylus here. So you take swab number 1 and you streak it like this. And then you take swab number 2. I'm not going to change the color, you guys, but imagine this is a different swab, and you go like this. And then you can isolate where they intersect, and you can hope that you get something that has bred with each other. So that's kind of a variation on double swabbing. Some people will take a swab. A swab is like a sterile cotton bud. Some people, if you have 2 mushrooms growing at the same time, you can take the same swab and you can get spores from 2 separate mushrooms. So it's like you're mixing them on the swab. Most people prefer to do it on a plate. Again, you can do like a sort of tic-tac-toe thing. And then you get your other color. Here, let me just change the color here. I'm terrified to. Let's see if I change the color here. So you get your other, spores, and you do this. And then you hope there at the intersections, you might find something interesting. So this is sometimes called double swabbing or ghetto swabbing. And I think I've heard Andrew talk about this one time. This works really, really well too. And it's fairly straightforward. And you just kind of, it's like a luck of the draw kind of thing. I mean, worst case scenario is you isolate a new isolate of the thing you already got. And so that is not such a bad thing, because it's often good to go back to spores. Sometimes your strains will get tired. And so either way, if you go back to spores and you re-isolate a black pearl, it's not the end of the world, right? Because you've just got a newer, fresher, hopefully similar phenotype to the old black pearl that you got the spores from. You could have some variation. It kind of depends on how stabilized and inbred it is. But in you're trying to essentially get a cross between 2 different types of spores. So that, again, it's like a crapshoot kind of thing. So that's called double swabbing or ghetto swabbing. And there's a couple other variations on that too. As I mentioned, you can go and you can mix, 2 multi-spore syringes on the same plate or in the same substrate. So germination plates of T0 spawn. So what I mentioned and what I just showed you there, that's what's called T0. T0 for most people means the germination plate, or sometimes people call them the streak plate. So again, depending on who you are, you might say streak plate, germination plate, or the T0 plate. T indicates transfer. So 0 means like you haven't made any transfers yet. So it just means essentially that, you're getting ready to transfer it. So it's the T0 plate. But again, you can use whatever terminology you like. Another variation on this thing is, let's say you already, and this is what I'm going to focus on here in a little bit. This is called a daimon or a buller. And I don't know how to erase my stuff, you guys. So sorry. The daimon and the mon. These are what you would really start to get into. Like if you were saying like a systematic planned out breeding program, then you're starting to talk about daimons and mon. The reason why it's more systematic and why it's really, really cool and the preferred method for anyone who's going to do this for a while is you can grow monokaryons by themselves on a separate plate. So this, again, I can't overstate the importance of this enough. If you are breeding dogs or cats or plants, this is something you cannot do without an extreme amount of technology and money and lab space and equipment. We can, in our home labs, you can take a spore and you can isolate it as a haplo. Sorry, guys, my light out there. It's trying to die on me. If you see it blinking, it's not technical issues. It's just my light bulb. You can take these spores and you can germinate them and you can grow the haploid organism. So it's half of the genetic complement of this full organism. And you can grow it completely independently on a plate, and you can subculture it and you can grow it over and over and over again. So that means when you can grow this thing on a plate, you can say you've got one monokaryon. You can isolate that and grow it again and again and again. And you can take it and you can mate it with number 1, number 2, number 3, number 4. So if you have, let's say, 6 dikaryons and you have 1 mono, that means you can make 6 separate crosses. So this is what's called the buller phenomenon. If you have, let's say, 6 monokaryons, the numbers start to get enormous. So just as an example, let's say I have 10 monokaryons. Okay, so this is where the 10 monos. Sorry guys, I'm writing on my screen here. This is not gonna look great. If I have 10 monos, here's the math, you guys. If you can do the equation is 10 minus 9. Anyway, you guys are gonna get messy. It's 90 divided by 2. And so that means with 10 monokaryons, you can make 45 unique crosses. That means with 10 monokaryons, 10 spores from either the same mushroom or 10 different mushrooms or 10 different types or strains or whatever, you can make 45 novel, unique combinations that have never, ever been made in the entire world. And so that means you can get 45 potentially new phenotypes. This is why you're probably in this class, is because that's what we're looking for, right? We're looking for new phenotypes. And so if you really, really want to get into this, you start isolating monos. You keep those monos separate from all your other spores and all your other contaminants, and you make darn sure, they're well taken care of. You make things like backups of them. You put them in water storage. You use the Castellani method to put them in water storage. You can store monokaryons. Where I went to graduate school, we had 60,000 monokaryon isolates in these little cryo vials. I don't have one laying around here, but these little tiny tubes, or you can put them in glass vials or slants or whatever you choose, and you can keep them forever, basically, if you want to. as long as they don't get contaminated or you don't accidentally freeze them or they don't, they don't die for some other reason. And so this is the kind of thing that if you're going to be a breeder in the future and you want to start doing this now, you want to definitely get up to speed on how you preserve cultures, how you do slants, the water storage method, and basically make sure your tissue culture techniques, your sterility and all that stuff is up to speed. Because once you do the effort or put in the effort to isolate these things, these monos, they are quite valuable. So this is where money starts getting involved, because if you have an isolate, a mono carrion, you can sell them to people. I sold a few for $125 a piece because it took me 3 months to isolate and test and then breed them with some other things. And so I knew that they were good. And there's still people to this day. I sold them probably 4 years ago. There's still people to this day using those isolates they bought from me. So for a couple guys I know in Colorado, it was $125 well spent. This guy bought a leucistic swamp ghost and a toke mono, and they have worked out very, very well for him. And so the problem with that is once you share these things, they're out there. The culture vultures are going to get a hold of it. People are going to share it with their friends. That's fine. That's what happens. There's no stopping that. So those are mods. I'll move on here a little bit. You can talk about DDK or de-dikeratization. That's not really something that I think the average person is up for. It involves things like centrifuges and proteases and chitinases and a bunch of enzymes, polyethylene glycol and all this stuff that people probably don't want to get involved with. It's like a lot more lab and time intensive, like equipment intensive and chemical intensive. And then kind of the other side of that, what we call protoplast fusion. If you get in the literature, you'll hear a lot about that protoplast fusion. And that's, again, an ongoing controversy, whether certain things were actually made using protoplast fusion, which leads me to the next one, the snake venom thing. If you've ever been on the shroomery back in the day, I think it was PE6 was supposedly was made from B+ and a tat or something like that. And that's supposedly where we got PE6. Anyway, snake venom, it's a protease. It basically causes the cell walls to break down, and you get these things called protoplasts, and they can sometimes fuse together and create a new dikaryon. So that type of thing, the DDK, is particularly important if you have a pre-existing strain that is good, like say Enigma is the prime example, or one of the blob mutations. They don't produce spores, but you want to breed that with something else. Then you're going to have to either make protoplasts and do the DDK procedure, or you do diamonds, which I'll show you how to do a little bit later. It's very straightforward. Where you take a dikaryon and a monokaryon and you put them on a plate, and one of those nuclei from the dikaryon will migrate into the monokaryon. And then liquid fragmentation is another one that's like, okay, this is a little bit sketchy. Some people claim that they maybe what they call blender tech in the past, where you would essentially take a dikaryon and you put it in a blender and you mix the heck out of it, and supposedly those mycelial fragments can recombine and you somehow magically reconstitute a dikaryon from these chunks of mycelium, and maybe they mix with each other if you put two dikaryons in there. Very, very kind of skeptical whether that's actually worked or not, but some people claim it has. And there's another one that really nobody's really done much with. It's called polyploidization. I'll talk maybe a little bit about that more later. You can use chemicals like colchicine, which is a gout medication, fluconazole, which is a fairly readily available antibiotic, and orozalin, which is a chemical that I don't think is readily available, but you could probably track it down. Anyway, these are things that mess with the mitotic spindle apparatus. So when cells divide in mitosis, there's these little things that essentially pull apart the chromosomes and do a bunch of other stuff. If that apparatus, they're kind of like little pulleys. If you disrupt that apparatus, you can sometimes get a duplication event where the nuclei, instead of having maybe 2 sets of chromosomes, will have 4 or 6, and those are called polyploids. Most agricultural crops like maize and wheat and soybeans and even things like sunflowers are what we call polyploids. In the plant world, it's quite common, and it usually, they don't really know why it happens, but it tends to increase the output of the plant that results from these polyploidization events. And so I've been trying to encourage this by putting colchicine in my media. And so I don't know, we can talk about that more later if you want to. You probably heard the term heterosis or hybrid vigor. That's essentially, like I was talking about, F1 hybrid corn in America. There's another reason why you might want to do that. Oftentimes the F2 will not breed true, as they say. So it's kind of like heirloom tomatoes or heirloom cucumbers or whatever. Heirloom varieties have been inbred and have been around for so long that they can breed true. If you get seeds from an heirloom tomato, it will make the same tomato again and again and again. Because of Mendelian genetics and this whole hybridization that occurs and this mixing up of the chromosomes, when meiosis occurs, i.e. going to the F2 generation, you get a reassortment of these chromosomes. And so the new generation, the new filial generation, will not breed true or be true breeding. And so that's why the corn seed companies do that. It's essentially a way to prevent farmers from saving seed for next year. So they need to buy the same F1 hybrid seed again. And because the seed companies they're not going to tell you what the mommy and daddy were. So they make that F1 hybrid seed and they sell it year after year after year because the yields are so good. But the only people who have access to that, those 2 parents are the seed company. So there would probably be some nefarious way that you could use that in fungi too. But I don't know if anybody's really going to go there. I.e. you could probably maybe breed like a sporeless variety of mushrooms, maybe. Again, that's going back to the whole cordyceps, mon regeneration of fruiting strains and things like that. But anyway, we might as well move on here. Let me read the comments here again, you guys. I'm getting kind of blah, 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 blabbering on here. How do we keep, let's see, what is this? Can't read my windows chopped off here. Strand Farmer, how do we keep cultures? Maybe, is that what you mean? Wasn't there something about the branching ale mono? Yeah, Vincent, there is something about, so what I noticed after looking at literally thousands, that's the thing. I did all of this stuff for back in grad school too, and I didn't realize this implication because I was using it for a different reason. We isolated monos so that we could get a cleaner DNA sequence. I didn't have time to do any breeding studies really, but I noticed that yes, in monokaryons, at least in cubensis, the angle of branching tends to be more like 90 degrees. And I think this is a result of essentially those 2 nuclei in a dikaryon, the way they migrate to the next cell when mitosis occurs. I think it has something to do with that. It's just a steric constraint, what they would call it. It's like there's no space in there. So, but yeah, I wouldn't take that as the kind of gospel either. Because that's really, really hard and it's not consistent. I just kind of noticed after a while that the monokaryons that I did isolate tended to have more perpendicular branching. But I wouldn't take that as proof that it's a mono because you can have fairly almost close to 90-degree branching in a normal dikaryon also. So I wouldn't use that as a characteristic, defining characteristic. So wondering how to keep a mono without getting old or senescing. Senescence is not really, I think, an issue that we don't need to talk about this really in this conversation, because senescence is something that usually involves a fruiting strain. And if you have a mono, I don't really think that senescence is going to be a problem because you're not fruiting it. One of the things I meant to mention earlier that I kind of forgot is that monokaryons won't make fruit. Monokaryons won't make mushrooms. So if you have what you think is a monokaryon and you see like a plate pin, you see like, yeah, I don't have any over here, but if you see a little mushroom growing on a plate that you think is a monokaryon, it's not a monokaryon. And also the senescence thing is not really an issue because senescence is going to happen after you already have a dikaryon. And so senescence in the sense, I hate to say it, but people use that word very loosely and they generally kind of don't know what they're talking about. Senescence in the more technical sense means that essentially the telomeres on the ends of those DNA, every time a cell goes through mitosis and it doubles itself essentially, there's little markers in there and little things that happen to the end of the chromosomes. And so those get shorter and shorter and shorter. But if you were starting with 2 monokaryons and reconstituting a dikaryon, that by default is going to undergo meiosis before it ever gets to the point where it would senesce, because senescence is a product of essentially mitotic division. And when you go through meiosis, which is what's going to happen when you mix a monokaryon with another monokaryon, it's going to combine, they're going to fuse, it's going to undergo meiosis. Meiosis, M-E-I-O-S-I-S. So there's mitosis with a T, M-I-T. That's where you just, normal growth. Meiosis, M-E-I-O-S-I-S. That's where essentially those two, all the chromosomes are going to come together and jumble up, and you're going to get a whole new set of recombinations. And so that process of meiosis resets all that thing. It's kind of the same thing when a baby's born. You can kind of think about a sperm and an egg come together, and even maybe though the dad's old and the mom's old, when the baby's born, you don't get like an old baby, right? I mean, that's probably a pretty good analogy. Like the mom who's 40 and the dad who's 55, like the baby's not old when it comes out, right? And that's because when the sperm and the egg come together, this whole process of meiosis, recombination, etc., it basically resets everything. And so the sperm is kind of like sperm from a 50-year-old guy and sperm from a 20-year-old guy is still sperm. There's maybe some caveats in there and, 30 years of smoking and drinking or whatever. But in general, when sperm are produced on a daily basis, like in male testes, they're going to be new. There's nothing like, there's not like old sperm because that sperm is a product of meiosis. And so meiosis, that process, it recreates kind of fresh stuff. So senescence wouldn't really be an appropriate thing to discuss, especially with monokaryons. And in the context, the larger context, that could be like a 5 or 6 hour discussion. So maybe we shouldn't really go there. Another thing, I had some heated debates with people over the years. People use the term senescence very kind of loosely. Senescence is not synonymous with old age or aging, but people sometimes use it in that context. And it's not really the right way to use the word. So let's see, move on to another thing here. Let me see. Let's see. I remember someone, Andrew, probably mentioning that, or what most people call senescence would be. Yep, exactly, Vincent. So yeah, that's a whole other very long discussion. But it doesn't have anything to do with monokaryons. You don't need to worry about, if you're worried about, you don't need to worry about senescence. If you're gonna breed mushrooms, senescence is like the last thing you need to worry about. So here's, as I was saying, these are the different levels of like how much time, resources, labor, heartache, depression, anti-anxiety medicines. How much effort do you want to put into breeding? So like I said, I've pretty much talked about all this stuff already. You can just simply mix spore prints. I mean, this could be something as simple as taking a cooled scalpel blade and scraping off, taking your one spore print and you scrape. You got your first spore print, you take it, you got your open petri dish, you scrape. Spore print number 2, scrape, and put them on a petri dish and see what grows. There's that level of thing. Of course, like I said, the multi-spore syringes, you either shoot them into the same substrate or shoot them onto a plate. Like I said, there's double, ghetto, swabbing, and streaking. There's different methods to do that. Tic-tac-toe, just blast the whole plate with both of them. Or you can use the same swab on 2 different mushrooms. If you just happen to have, 2 mushrooms, like, hey, I got a GT and a B+ growing together, which brings up a good point. When you're breeding mushrooms or anything else, you want to generally have something that is going to be distinguishable from the parents, right? So it's kind of would be a bit pointless to breed 2 mushrooms together and get something that looks like the parents, right? Because you already got the parents. Like, why would you need another thing that looks like the parents? But like I said, if you were looking for albinos or you were looking for these weird recessive traits, that might be helpful. So yeah, you can do that, breed 2 things together. In fact, you can do the same thing. Let's say you only have GT. Now sorry, I'm using all these cubensis references, you guys, because that's what I'm most familiar with. The reason why, like literally the hundreds of different kinds of albino Louis Vuitton and toques and, twisted albino stargazer and whatever else. I got, Ghost, PE, Melmax, Emerald Gates, whatever it might be. These things all came from a GT spore print. Like literally all of the hundreds of things. You go onto some of these vendor sites and you see they literally have 200-300 things listed. Those all came from a Golden Teacher spore print. All of them. Well, thousands, tens of thousands, probably hundreds of thousands of man hours, and tons of petri dishes and substrate and whatnot. That's where we got all these things, all these cool genetic variations on cubensis. That look so different. I mean, they all look a little different, but anyway, those were all from just basically a spore print, and spores. And so yeah, then we get into the isolated monokaryons. Like I said, there's a couple techniques I'll show you guys here in a second. It's what we call spore drops. So you can take a petri dish and you can take Vaseline. I don't know, you can take a piece of Vaseline or any kind of like glue or whatever, and you put it on the inside of the plate. And then you take a gill fragment and you adhere it to that Vaseline or whatever jelly, petroleum jelly. And then you take the plate, and if you imagine it was sitting like this, the spores would fall straight down, right, onto your agar. So what you do is you turn it sideways. And then, so now you got the spores ejecting like a couple micrometers, from the hilar appendage there, and then they just fall down. Not the hilar appendage, though. What's that thing called? A sterigmata. And then they just sort of fall down. And if you get this at just the right angle, you can get those spores to fall down, and they might just find the single colony. And if you're fast enough and you look sharp enough and you pay enough attention, you might be able to isolate one of those single spores as it falls down and adheres to that agar and grows into a colony. So that's what's called a spore drop. There's a couple other variations on that, but that's the basic idea. You can put it higher if you wanted to. If you use baby food jars for your agar, you can just like put a whole mushroom cap above the agar for like 5 minutes, and enough spores will probably fall down that you could maybe isolate a single spore. So that's kind of called a spore drop. Serial dilution is the one that's probably the most annoying, to be honest. Serial dilution is where you take a tube, and so in this first tube you'll take your spores, and we call this like 1x. I don't know why I'm doing this. I got my stylus. So there you have a 1x. And then you take a little bit of this and you put it into a new tube, and then you dilute it with 10 times the amount of water, or 9 times the water. You call that 10x. And then you shake that around. And then you put this into another tube and you call that 100x. So essentially, if you had like 10 mLs of water, you put 9 mLs of water and you put 1 ml of this, and then you put that into 9, and so that dilutes it 10 times. So this is what we call serial dilution, and you can do that to 1,000 or whatever. This is what's called serial dilution. And so that, as you can see, it takes a bunch of time, and it's tedious, and it's prone to contamination because you're using things like pipettes and all this stuff. But that's been the standard way. Mostly in microbiology, they use that for what are called plate counts. So if you do a little bit of math, and let's see if you're on, say, your 1,000x plates, you got 5 colonies. Well, that means that on your 1x, you would have had 5,000 colonies. So if you've got a sample of, like, say, I don't know, toilet water or urine or something like that, or something that has a high bacterial count, if you just shoot them directly onto a media plate, you're not going to be able to count them. So you need to dilute them so you can see individual colonies. So that's where that technique derived from, and why we used it. And that's still used quite frequently in microbiology. In fact, that if you ever take microbiology, that'll be like one of the first things you learn in the like second or third lab is how to do serial dilution so you can count bacteria. And then you do your little calculation and find out how many bacteria were in your, toilet water or whatever. So you can do the same thing with spores, and you can use things like Tween. There's other kinds of like detergents like Dawn dish soap. You just take a little tiny little bit of dish soap and you put it in there as a surfactant. And what that allows the spores to separate individually, so that you're not getting like clumps of spores. So again, that's called serial dilution. And the thing that I kind of came up with is a kind of modified version of streaking plates. It's called grab and drag, and I can go into that in more detail later. Essentially, you get a tiny little piece of your swab. So imagine you've got like your cotton swab. You take a tweezers or a the back of the scalpel blade will work. And you try to get like one little single thread of a cotton swab, and you use that. It might have, say, 100 spores on it. And as you make this sort of serpentine pattern, like I did, I don't know how well you can see that, you make this sort of serpentine pattern through the media as you kind of like an S shape. Can't really see it now because they're growing everywhere. But you make sort of like an S shape. And as you're doing that with the same piece of cotton, you will hopefully deposit single spores along that line. Like, I don't know if you can see, there's some places the spores are growing and sometimes they're not. So I isolated little, like this was about 5 days ago, I isolated little pieces where I saw colonies growing, and I will check them. I will check them later to see if they're monokaryons. So those 3 things I got in there really quick with a really sharp scalpel, and I isolated what hopefully will be single spores and monokaryotic cultures, so that I can use them to breed and do my diamond crosses later on. Let's see. I serial dilute with syringes and double dilute. Okay. Yep, that works too. Grow fresh. Yep, that works pretty well too. If you have access to syringes, you can do the same exact thing. Yeah, I saw Dave Wombat. He did a cool thing where he was like shooting out. How did he do it? Yeah, there's other ways you can do it. What was he doing? He was like shooting out, like pull up like 10 mLs and then shooting out like 9. And then like pulling up 9 of fresh water and then shooting that onto a plate and then squirting out 9 and then pulling up 9 fresh. Yeah, you can do that too. Works really well. Yeah, that's if you want. I kind of kind of sentimental about the grab and drag. But yeah, that works really well too. Yeah, it was funny. I didn't, for some reason, that was another thing. Somebody should probably publicize that kind of thing more in the online mycological community, because I only ever saw Dave Wombat do that one time. And it's a brilliant idea. If you just have a single syringe, it's a brilliant idea. And you can just basically use the one syringe and do the whole 1x, 10x, 100x, 1000x in like a single syringe. But I've only ever seen that like one time. I saw Dave Wombat and he only mentioned it. He mentioned it one time in like a little video. And that's the only time I've ever heard anybody talk about it. So somebody should make a video about that. See, so the diamonds, we'll get down to that. Monmons, we already talked about. Yeah, we already talked about that. And genetic energy engineering, we're not going to go there today, I don't think. So let's see. There's a blank drawing slide. So how do we distribute spores these days? A lot of people get them on swabs. You can make spore prints. I'm assuming you guys probably know how to make a spore print. And spores, the thing with spores, I put this slide in here because I think a lot of people don't really fully understand or know what a spore is. In fact, this is one of the most common misconceptions, I think, between when people are using liquid culture and multi-spore syringes. They don't really quite understand that what a spore is, and that multi-spore syringes have spores suspended in them. And this is partially to blame on the vendor community, because vendors were honestly selling liquid culture before it was like kind of accepted as legal, quote unquote, in the community. And a lot of things, I know, especially I was ordering spore syringes from Europe that were clearly not spores. They were clearly liquid culture. And I didn't care because, you know, I was just going to shoot them into grain anyways and make spawn. But these were clearly mycelial cultures suspended in water or whatever media they had used, and they were not spores. And so this confusion maybe also comes from the fact that people don't realize how small spores are. Spores are like, we're talking like 5 to 10 microns, which is like 5/1000ths of an inch. Which is tiny. Well, it's not an inch. A micron is it's a millionth of a meter, right? So it's 1,000th of a millimeter. Anyway, it's really, really, really tiny. It's like I don't know, like, you know, you can see. So when you look at these swabs, you see all that black stuff on there. That's the spores in mass. That represents literally like tens of thousands, if not hundreds of thousands of spores. And when you actually look under the microscope, it becomes really obvious that most of those spores don't germinate. Otherwise, you know, it'd be very, very easy to get cultures. And so oftentimes if you get swabbed, especially if they're older, or even a spore print, it might have millions of spores and not all of them germinate. For whatever reason, who knows? So the idea is to, and my idea in my head with all this, like, you know, grab and drag thing, was to take the spores that maybe germinate and don't germinate and kind of separate them. And so that you can maybe, so it's kind of funny. It actually came from the fact that I got some spore swabs from someone else that didn't have any spores on them, because somebody had swabbed the fruit prematurely, and they just basically didn't have any spores. And I was trying to figure out a way also that I could take spore swabs that maybe had contaminants on them. So a lot of these techniques, the original reason they use, like, say, cereal dilution, was to isolate not only the same kind of bacteria or whatever it might be from its neighbors and from its, you know, brothers and sisters, so that they could be counted, but also if you had a mixed preparation, if you had something that had, say, 4 or 5 different types of bacteria in them, certain types of bacteria like bacillus, you know, subtilis, or, you know, staphylococcus aureus, they grow so quickly on our standard media that have sugar in them that the staphylococcus aureus would overwhelm anything else that might be in that sample. So in order to differentiate between the different types of bacteria in that sample, you needed to separate them out and let them grow by themselves. So something that grows much more slowly would just be overwhelmed by some of the other bacteria, and you wouldn't see it. And like I said before, you also wouldn't be able to count them, because, you know, what's the difference between 1 bacteria and 100, you know, when it's like a blob on a media plate? Like, you can't really differentiate whether that started off as 1 bacterium and it multiplied, or was that 1,000 bacteria. And so, again, that's why we originally did cereal dilution, was to do that. So, but yeah. Again, so yeah, spores are really small. You can get prints these days, like I said, multi-spore syringes, swabs, and the liquid culture is a new thing. I think it's just been maybe 3 or 4 years where liquid culture has been really, really popular. I guess in Europe they were already selling it, but in America, liquid culture has just really become super duper popular in the last maybe 4 or 5 years. And I don't know, I guess the gourmet world kind of caught onto it a little bit quicker than like the cubensis world did. I think you guys have been able to get, I don't know, liquid culture for probably 10 years or so. But I'm not really sure. I didn't kind of follow the trends in the gourmet world that yeah, I did grow gourmets, but I usually just grew them from clones of stuff that I got from the grocery store. So anywho, for anybody out there who doesn't know the mushroom life cycle, I put a couple slides in here. So what we're trying to get is these things right here, these single spores. And if you look here, this slide illustrates something else that is quite important, is that spores don't have sexes. So we sometimes designate them plus and minus. I don't know how well you can see that there, but there's a little plus there. The plus and minus are to distinguish them from each other, but they have other than that, they have none. That has no significance. It's not plus and minus. It's not like it's not like sort of, what do you call a subjective kind of, it's not like one's good, one's bad or something like that. It's just to differentiate them. Some people would call those sexes. That's not really right. And it's a simple reason, because sexes are distinguished from each other by some sort of morphological difference. Spores have no morphological difference. Simple as that. The fancy word for that is they're called isogamous. It means that the gametes are all the same size. So the opposite of that, or the other part of this, I think it's called anisogamous, which means that they're not the same size. They're different sizes. So like, for instance, a sperm and an egg are dramatically different sizes, right? So you could distinguish sexes based on, who produces the sperm and who produces the egg. I know that might be some controversial these days, but whatever. Mushrooms, there's really no way to tell the sexes. And this is where you'll get these articles for things like Schizophilum communa, the split gill, and they'll say, oh, this mushroom has 10,000 sexes. That's not really, I mean, again, they're trying to, grab the headlines. But what it really means is essentially they have 10,000 different mating types. And so that's, again, something genetically we can get into. But the key thing is that in fungi, you really only need two different spores. That's it. It doesn't really matter if they're, whatever. One's pink, blue, orange, green. If you want to call those different sexes, it doesn't matter. The blue and the yellow one, the blue and the green, the blue and the purple, the blue and the black, whatever. They can all mate with each other. But there's a little more subtlety to that, in where we have bipolar and tetrapolar mating systems. But again, I don't think we need to get in that today. But for all intensive purposes, it means that everything can mate with another thing. So two spores, and most of the time with the numbers we're dealing with, they can mate with each other. Again, we can talk about bipolar and tetrapolar mating systems if you want, but I don't think it's really necessary. They will sometimes, some of the people in the medicinal world, if they want to sound fancy and all academic because they just read a paper about mating systems, they'll start to go into excruciating detail about pheromones and mating alleles and blah, blah, blah. This one forms clamps, and this is another, whatever. Good luck for them. We're not going to do that unless somebody really, really wants to. Let's see here. I've got syringes, although I'm reading the comment here. I got syringes all the way to 10,000. Oh, I've got syringes all the way. Screen all these. I see something. I always have it back. Yeah, grow fresh. You can do that if you want. That's probably usually not. if you want to. Yeah, that's very systematic. I did that the first couple times I did serial dilutions, but if your purpose is to get two spores to mate with each other, that might be a little bit of an excessive amount of work, but yeah, you can get as detailed as, you can get as meticulous as you want as far as that goes. But in general, when you get a single spore, it doesn't really matter which way you get it. So again, one of those things, a lot of people have their favorite techniques, and they kind of it's like football teams or basketball teams. People are like, oh, that's team's the best, and that's the only one I root for. At the end of the day, if you get a single spore and a monokaryon culture from that spore, it doesn't matter how you did it. In fact, this is a bit of kind of irony here, is that MVP, the monos that I have right here, the very first time I started a culture of MVP, speaking of sports, but it's most valuable producer, I started a culture of MVP from swabs, and I tried to fruit it three times, and I had monotubs, giant monotubs full of spawn and substrate of MVP, what I thought was fruiting culture. Turns out it was monokaryon. So after the third time I tried to fruit it, I was really confused, and I ripped off a piece of the mycelium from the substrate and looked at it under the microscope and realized that there were no clamp connections, and I had a monokaryon. So this forever burned the fact in my head that monokaryons do not make fruit. A monokaryon would not fruit and make a mushroom. So this is the same idea. Like, if you just have an egg, it can't make a human. If you have sperm, it can't make a human. You need a sperm and an egg. And so that's one of the things that I kind of learned the hard way. So the other side of that coin is that if you see a culture that is supposed to be a monokaryon and it has a little fruit on it, like a pin, a little baby mushroom, it is not a monokaryon. And then you could talk about homothalism and a couple other things, but we don't need to go there either. So the basic idea here, these two things come together, they fuse. This is what we call anastomosis. Some people use the term and the word anastomosis a little bit differently. But essentially these two hyphal kind of individuals fuse together, and they may or may not exchange nuclei with each other. We'll just say they do for this example. So now you have what's called a dikaryon, and that goes on to form a mushroom. That mushroom forms gills, and on those gills it forms basidia, and on those basidia the spores are born. And so there's a single cell. I think I might have a better, there might be another slide down the way. On those basidia, and in that basidial cell, there is a single cell at which that organism, what we call the mushroom, the basidiomycete mushroom, it goes from two separate haploid nuclei. They fuse together, become what's called a diploid, which is 2N. And then immediately undergo meiosis to form 4 spores. That's MEI. So then you get these haploid nuclei. So you get 4 of these. Okay, so we go from N plus N, which is our dikaryon, and then it goes to a diploid in the basidia, and then that undergoes meiosis. That's the M. Sorry, guys. I'm used to writing on a big old whiteboard, so this is really awkward to me. And this is where we get our spores, and those go back to being haploids. So we've completed the circle here, right? So we started off here N, then we got N plus N, and then right up here we go 2N, and then we go back to N, and that's it. That's a mushroom life cycle. Ta-da! So then this is you guys, some of y'all probably recognize this. This is from the Paul Stamets book. I think every Paul Stamets book has this diagram in it. But yeah, all of that stuff and a few of the extra things you need to do. This slide essentially describes mushroom cultivation. And there's a whole bunch of variations on it, but I'm sure y'all are very familiar with this. Let's see. Let me see. Let me read some of these things here. Let's see. Grow fresh is mostly until I get very comfortable with the microscope. See, grow fresh. Yeah. If you're doing spores and you're keeping them in water, especially if you mix them with detergent like tween or some surfactant, I wouldn't probably want to keep them too long. I didn't have very good luck if you want to use them fresh. I didn't have good luck with spore dilutions kept in the refrigerator. If they're in sterile water, maybe, but once the spores are sort of floating around water, if there's any bacteria on those spores, they'll tend to get mixed in. And so a lot of times, I don't know, I didn't have good luck with that, but people sell spore syringes all the time. So I don't know, maybe it's fine. Let's see, Vincent. I guess it also depends what you want the serial dilution for. If you want a mono that you want to manually pair versus for selection to compensate for all. I guess it also depends what you use the serial dilution for. If you want a mono that you yeah, sorry, Vincent. I'm not really sure how the second part is related to the first part there. Manually pair versus for selection to compensate for all the fast growers to get. Oh yeah, so I think you're talking about whether you're doing like a mass spore thing, or you're talking about like something like a multi-spore and shooting it into a. Yeah. I mean, I guess I understand what you're saying. The whole idea with mono is if you're going to go through the effort to create or isolate monos, you're probably got a much bigger plan involved and not just looking for something that grows faster. It's kind of a numbers game again too. I mean, if you're growing, like, let's say you're growing GT and you're growing 1,000 monotubs, even if you're doing multi-spore syringes, at some point you're going to see a weird phenotype. But if you, I don't know. Yeah, I know what you're saying. I'm not sure. It really I guess it depends. Yeah, it depends what your goal is and how precise you want to be. One of the big things, the main thing with monokaryons is that it's reproducible. I think that's what you're getting at. The main thing with monokaryons is that it's almost like a bit of a flex, and I notice it in the online mushroom community, is that if you got the ability to make monos, like it makes you like, it's kind of like, oh, like I got my monos, and it's kind of like a flex, like a peacocking thing that a lot of people get into. Once they supposedly have isolated their own monos, it's kind of like, ooh, like I'm kind of like better, I'm more advanced than you. It's kind of like in the medicinal world when people like advance from like cubensis to paniolus, and then they go to other exotics, like, they grow semi-lanciata outdoors, or they grow cerulescens or something like that. It's kind of like a flex. There's a lot of ego, kind of chest beating in the mycology world. So yeah, it's a bunch of young guys who want to show their virility, and how strong they are. So it's a lot of that going on. So you probably want microscopy in the first case, but might be optional the second one. I think it just depends on how precise you want to be, and how reproducible. As I was saying, the best thing about monos is that you can grow them separately. So if you're doing more like a bulk mass inoculation, or using multi-spores, or you're doing ghetto swabbing or double swabbing or a lot of those other things, you're not going to be able to reproduce it. So that's going to be like a one-off. I don't know if it's necessarily about the the how fast they grow or whatever. It's just that you're not going to be able to reproduce it. So you're going to be growing whatever grows that time, but you're never going to be able to reproduce it. Whereas if I have a mono, say mono 1 and mono 5, and I get something, I can send you mono 1 and mono 5, and you can recreate the same thing. This is the idea with the cordyceps breeders, is that they have isolated monos. And so when they make a new strain that they sell, they know that it was like mono number 3 and mono number 7. That was a good combination. Mono number 2 and mono number 6, not so good. Mono number 2 and number 8, good. Mono number 8, number 9, not good. So they can recreate that matching, that pairing. So this is like I was saying, the same thing that the corn breeders or whatever plant breeders, they do the same thing with rice and whatever else, wheat. They can reproduce that pairing. That's the biggest reason why you would put all this effort into doing this. So that if somebody doesn't believe you, you can say, well, here's my monos, here they are, you do it yourself. Not that ever is going to happen, but like you could potentially recreate this thing. So if I took, a mono from a Louis Vuitton and a mono from I don't know, an albino golden teacher, whatever, I could recreate them. And so this is what, as far as the gourmet community goes, this is probably something, actually, I should probably talk more. This is about Psilocybe cubensis, but it's the same basic idea for all mushrooms. The power here comes in that you can save, like I mentioned before, you can save and share your monokaryons. And so years from now, if you have 2 monokaryons that you use to create something, and for whatever reason you lost that creation, you can go back to the original monos and you can recreate it. Not only that, you can send it to your friends. So one of the cool things, and I thought, I was a little surprised, but I guess the gourmet community is just as guarded and gate kept as the magic community, is that people don't share stuff. What the gourmet community, if they had maybe, I don't know, a little more cooperation, sharing monokaryons would be a brilliant thing, or creating a monokaryon like repository, like a culture collection, so that people could, like Pokemons or whatever, share, swap, trade monos. That would be awesome. I tried sort of doing that in the cubensis community, and it just turned into just a mess, because people inevitably put some kind of value on their mono, and their mono is better than somebody else's. And so it becomes sort of, again, a peacocking kind of, for lack of a better word, like a dick swinging contest, like who's, and that just, I'm sure it's the same way in the gourmet world as it is in that world. That's just the way human males are, right? Anyway, let's see. Should I look into getting a microscope to teach a microscope? Should I look into getting a microscopist to teach a miner? Teaching you to get a... No, you can learn everything you need to know about microscopy on the internet, and I will show you some more things here in a little bit. The only thing you really need a microscope for mycology is looking at spores if you're trying to identify wild mushrooms. Like, I don't know if you saw back here, some of these spores, they have very distinctive, like you can see these have little bumps on them. And the shapes, and like these have little ridges on them and things like that. The only reason you would need a microscope is to see that kind of stuff, or measure their size, or look for clamp connections. So I'll get down to that here in a second. So this is the only thing you need a microscope for, is to look for these things called clamp connections. I'll be honest, you don't really need a microscope for anything other than that. I hate to say it, but that's really the only thing you need a microscope for, is to look for clamp connections, or to look at and measure spores. If you are going to get into field microscopy, field identification of things, you may want a microscope for that. But to be honest, 95% of the characteristics you're going to use to identify wild mushrooms, you don't need a microscope for. I wouldn't take a microscope. I don't even think you could find a microscopy class. And you could learn everything you want either online or the problem with doing microscopy on the internet is it's really hard to set up cameras and stuff with microscopes. I mean, you saw all that technical difficulty that me and Andrew were having at the beginning. Imagine I was here like using a microscope trying to show you guys how to do things on a microscope. It would be extremely difficult. And like I was thinking about maybe using my camera phone, the phone on my camera to show you guys, you know, some of my lab, but I'm not going to do that because the feedback, and then it might, I don't know, sharing stuff that way might be hard. I'm not sure, but that's not going to happen. But that's why a lot of people don't do microscopy stuff online, and you don't see videos about it because it's really, really tedious to like do that kind of stuff and make videos. See, grow fresh. I'm banking monos for now. Then once my confidence is up, would be to store the haploids. Yeah, I wouldn't wait for your confidence to get up. I would just start doing it, grow fresh. If you get a phenotype that you like, just, I don't know. There's no reason to wait. Cordyceps monos have a better chance to stay strong. Yeah, that's why somebody mentioned the senescence in the monos. I don't think that's something you need to worry about. In general, with monokaryons, you're not going to be subculture in them so much. Like you worry about senescence in dikaryon cultures, but remember you're multiplying that dikaryon culture like tens of thousands of times. So when cells undergo mitosis, like they divide, that's when you're going to pick up weird like mutations possibly or errors. The DNA gets old. It starts doing things like getting methylated and all this kind of stuff. The telomeres get shorter, et cetera, et cetera. You don't really need to worry about that with a monokaryon because number one, you're not going to grow a substantial amount of a monokaryon. And two, I just don't think the cellular apparatus are working in the same way as they would with a dikaryon. But the primary reason would be that you're just not gonna grow a bunch of monokaryon. Like you're gonna put it in water storage or you're gonna keep it on a slant in the refrigerator. So I don't think senescence is really even an issue with monokaryons. Super basic question. You can ask. I don't care how basic you think it is. It's probably not, and don't worry even if it is. Why isolate monos? So Strand Farmer, the cloning, you're cloning that individual. So monokaryons, you're trying to make something new. That's it. So the same reason why you go back to spores. Every time you go back to spores, you're trying to create something new. Cloning is, as the name implies, is an exact replica of what you have already. So the whole idea with breeding is generally you want to find new things. Although if you're breeding dogs, you may want to have a similar thing, and that's why you breed. You only breed like German Shepherds with other German Shepherds because you don't want something new. But if you wanted to find something new, you'd breed a German Shepherd, with a Basset Hound or whatever, and then that would be because you would want something new. But it's not really an advantage. It's not an advantage per se. It's the simple fact that you want to find something new. If you don't want to find something new, then clone. That's what cloning's for. But the whole premise of breeding is usually you want to find something new. But if you don't want to find something new, just clone. That's... Sorry, this is Andrew. Oh, Michael Miner. Oh, okay. Yeah, I was confused there. I was like, why is it sounds like... Oh, okay. Yeah, that's what I was wondering. I was like, this seems like Andrew asking a question. So yeah, I guess all that stuff I said that. I thought that was a participant asking the question. So yeah, Andrew, I wouldn't, I good luck finding somebody to do a microscopy class. I don't think you're gonna be able to find anybody. They were begging, everybody's been begging for somebody to do a microscopy. There's a couple guys I know who spent like $3,000 on microscopes with the intention of doing YouTube videos on microscopy. Like they bought like tripod microscopes and really expensive cameras and all this like, you know, mounting equipment, and they never produced anything. It's one of those, I think there's a limited interest in it, and because you really only need to learn how to do a couple things, it's not really probably something that is going to get a lot of views or anything. But, let's see. Yeah, I'm interested in learning to use a microscope for breeding, and that seems far at least simple enough to learn the right techniques. But also for mycology, as I do a lot of observation, identify I naturally there's quite a few I can't identify the species. Yeah, Vincent, even if you got a microscope, the problem will be you need the literature to tell you what species it is. So most of the common mushrooms, it's not gonna really help you identify a mushroom if you know what the spores look like. Because at that point, it's the genera of, so like say a Lactarius, there's like say 100 species of Lactarius in Tennessee. A microscope's not going to help you identify what species it is unless you have the book that tells you, well, Lactarius deliciosus and Lactarius fulmus and Lactarius blah blah quirkensis, or like you have to have the literature to tell you what the species are based on their spore characteristics. So microscopes may not even help you in that case. They would help you to differentiate, say, a Lactarius from a Colibia, you know, or a Pleurotus from a Lentinus maybe, but they're not going to help you differentiate species within a genus unless you have the appropriate literature. And I hear what it says, that it's mostly spores and Q ratio, but there also seems to be a lot more complex prep work that imply also get to learn to use theirs. Sir Vincent. Yeah, Vincent, I could very easily do a microscopy course, but like I just said, it's the technical equipment and whatnot. It's a pain in the butt. It's a long time you want to do some videos. Yeah, and like I said, there's not, like, people don't really care that much. It's got to the point where like a lot of people want you to do stuff, but they have a very transient interest in it. And once like they've got like a 5-minute window of interest, and as soon as they don't, then you kind of like, I did a lot of videos for people that made requests, and then like I never heard from those people again. So it was one of those things like, wow, yeah, I did a couple videos about how to find clamp connections, and like maybe 3 people interacted with those videos. So it's one of those things. A lot of people don't really, I don't know. It's one of those things like you can lead a horse to water, but you can't make them drink kind of thing. So that's a lot of things in life. Strand farmer. So it's impossible. So it's impossible to know what you will get until you cross monos and fruit. No, I would say impossible. You could make an educated guess. Like if you crossed a Chihuahua with a German Shepherd, I don't know, you could probably guess. I wouldn't say it's impossible. You're going to get a dog. But yeah, other than that, I mean, there's a lot of elements floating around in the genetics of these strains of mushrooms that you probably can't predict at this point. I don't think we're at the stage of mushroom genetics or human genetics where you can predict. I mean, you know what you and your brother and your sisters look like, but I don't think anybody could have predicted that. I don't think genetics is at that point quite yet. It's a way to search for can clone. Yep. Like you said there, Strand Farmer, you're not going to be able to predict. That's why I think it's slightly comical when people come up with names for mushrooms that they want to cross together based on just the 2 parents, because it's often something, you know, it's usually just something. I don't know. I wouldn't do it, but anyway. I think it might be time for a break here, guys. It's been 2.5 hours. To be honest, I'm gonna go have a cigarette because I'm like need some nicotine. It's 2:30 in the morning here, and so how about we let me read through the rest of these here because they're two very complex cells. There was one. Yeah, good luck with this Arpha Skypha. Good luck with all those Ascomycete cup fungi, Vincent. Yeah, that's a good. So we're going to take a break here. Let's take a 15-minute break, you guys. Right now on my computer, it is 2:34, about to turn 2:35. So let's see, what's that going to be? 40. How about we start again at 2:50? Okay, so 2:50. Whatever, in 15 minutes. I'm not sure you guys are all in different time zones too. So let's take 15-minute break, you guys. I gotta pee and have a smoke and refresh my Coke here. And let me put up, you guys, I'll put up the, I hope I can do it. Let me put up some of these slides. I totally forgot. You guys haven't I don't know if I can do it. You guys, I can't do the thing where I show you all your guys' man. I don't know if I can show you all the slides. But we got plenty more to talk about here, you guys. There's just give you guys some things here. I want to go through. Yeah, let me leave this slide. I want to show you guys a couple techniques, address that thing about some people saying how you can identify my monokaryons based on what they look like on the plate. You can't. I hate to tell you. Maybe something a little bit about mitochondrial DNA in this slide here, which is it's actually a diagram from that book that I mentioned. It's actually from this book. That book is brilliant. I don't know. That guy has a lot of stuff in his head about mushroom breeding, like way more than I ever did. Talk a little bit about phenohunting and cloning. So a lot of these questions, I think some of you guys are addressed or we're getting to. We're going to come back to those. And then maybe a little bit about some of the more advanced techniques. So yeah, anyway, well, I'm going to start going, I think, a little bit faster when I come back to the slides. So when we come back, let's resume. Let me put this slide up so you guys can ponder some of this stuff. Which slide here? I'll put up this slide. I think you guys should think of, yeah, there we go. Let's just put that up there for a while. If you guys have any questions, it is probably you guys know all that stuff. Where did it go? Sorry, guys, I can't see all the slides. I'm terrified to get. Here we go. Techniques we use. If you guys have any questions about that, when I come back, we can talk about any of those things. You guys can put your questions in the thing here. Yeah, and Vincent, I will share them on the. I'll send you guys the link to my Google Drive or whatever. Now, I'm terrified to do anything to mess with the Google Drive or any of that stuff now because yeah, let's just, as it's working now, let's just not mess with anything. But yeah, Vincent, I'll send a link later. I'll send it to Andrew and then he can forward it to you guys or whatever. So anyway, it's 15-minute start now here. So it's 37 here. So I'll see y'all at 52, whatever hour, 37 plus 52, wherever it is you're at. Okay, guys. A little bit early. I just realized I probably don't need to be wearing my headphones. I guess nobody's going to talk to me. So I probably don't need to keep these on. In fact, I think they turned off already. No input. I was just thinking while I was outside, you guys, one of the take-home message from all of this is you need to go back to spores. There are methods to get new phenotypes. I know Andrew's talked a lot about the UV lamps and things like that. There's the mutagens that you can put into your media. There are some scary things like various pesticides and weird things like azide amino this and that. And there's things like methyl ethyl sulfate and dimethyl sulfate and all these crazy things. But at the end of the day, if you're going to produce something new, you just need to go back to spores. You can get mutagenesis or mutations through using things like chemicals and radiation, probably, and ultraviolet, radiation lamps and things like that. I'm not sure how much variation. The problem with using chemicals or other kind of more mechanical means, electromagnetic or radiation means, is that you're gonna, in order to use enough of those chemicals or enough ultraviolet or enough whatever, I don't know, maybe weird media formulations, you're probably going to have to use enough of it that it'll possibly kill the fungus. So there's kind of a fine line. It's kind of like effective dose and the lethal dose for a lot of medications. There's sort of a fine line in the like therapeutic area, the therapeutic dose, where something's effective, but it doesn't kill you, but it may say kill bacteria or something like that, or cure some disease. So that's kind of the problem with using things like radiation and chemicals. The best way to get variation and to make sure that you have something that's still, close to what, say you're growing an oyster mushroom and you want to grow more oyster mushrooms, just a different kind, you probably want to use spores. Spores is just the easiest way. Mother Nature has provided this convenient way for us to generate genetic diversity, and that's through meiosis and sexual reproduction. Something else that you probably maybe have never thought about, a lot of fungi, certain things like aspergillus and some of the molds and contaminants that we encounter in mushroom production, the reason why they can reproduce so quickly and the reason why they're such a problem is because they're very specialized and they reproduce asexually. So they don't need to go through this whole kind of genetic recombination and this whole sexual dance to create new variations, because it's not necessary. Because if they're already adapted to grow on, sawdust or, soybean hulls or some sort of sugary media, they don't really need to change their approach very much. And so they often reproduce asexually, and that allows them to colonize new substrates, new ecological niches quite quickly, because they're quite literally clones of the previous, of the parent organism. So they use that technique to not change because they don't want to change. because they're already adapted or specialized or, I guess selected, evolved or whatever to utilize that particular ecological niche. So when you want to generate new variations, that's what sexual reproduction is for. That's at the end of the day, that's what natural selection is working on. It's working on that genetic variation that's recreated or that's created when things undergo meiosis and we produce those haploid spores. So that whole process that I'm not going to go into of meiosis, where you get this combining and then reassortment and production of new variations, that's what sexual selection is. And so that's what we want to take advantage of. So if you're trying to make something new, you want to go through spores. And again, that's what's brilliant about spores and working with spores, is that that's exactly the way Mother Nature does it. And so that's what we're trying to recreate. And here's some kind of questions that I think I kind of skipped this slide. It's kind of like you got to think about what's the goal of the final project. Do you really want to create something new? I mean, it's a lot of time and a lot of effort, and a lot of people just want to grow mushrooms that they can sell. So I don't know. I feel like sometimes maybe a lot of people that they love the idea of being a mushroom breeder, but it may be for reasons that are, I don't know. It's just kind of like a flex. Sometimes a lot of people want to say they're a mushroom breeder, they're a plant breeder, or they breed horses or they breed dogs. And I don't know. Sometimes I feel like it's more like people just trying to sort of, I don't know, flex and say they did it, which is kind of cool too, but I don't know. That's why I got into it. I mean, it was kind of a neat thing. I'm fascinated by the biology of it, but make sure you kind of want to get, kind of take the whole thing to fruition and literally, the fruit and I don't know. That's enough about that. So the other thing I was thinking about while I was outside is probably the easiest way to do this is to literally get spores. I don't know what kind of mushrooms you guys grow, but some people have grown mushrooms for years and they probably literally never taken a spore print. Getting a spore print is one of the kind of easiest ways to help you identify wild mushrooms, but it's also one of the easiest ways to preserve genetics. Spores will last for years, especially if you keep them in the refrigerator. If you're going to try to isolate monokaryons, you probably want to use spores that are as fresh as possible. Possibly even right off the mushroom. If you're doing something like the double swabbing thing, you could literally just have the mushroom here in your hand and, get spores and put them directly on an agar plate. If you want to do that little crisscrossing thing, or the double swabbing, you quite literally could take spores, or if you're doing the spore drop thing where you put the little piece of the gill tissue on the top of the agar plate and let them drop down. You're literally getting spores directly off the gill of the mushroom. And you want those probably to be fresher. There is something to be said too, maybe that the fresher spores or the ones that fall off first or the ones that germinate first are going to be, they're kind of going to be artificially selected for things that, germinate fast, which is generally what we want when we're growing things. We want them to grow faster, but that would be where something like serial dilution maybe would be better for picking up. And I think somebody mentioned that maybe picking up the slower growing things. Whereas, something like a mass spore inoculation or double swabbing, that would maybe get the things that would grow faster. Whereas if you're looking for something that might be a little more exotic, kind of like the runt of the litter, you might want to do the serial dilution, or you might want to, I think that was maybe what somebody was talking about, maybe purposely selecting spores based on just kind of random spores instead of the ones that sort of germinate faster or grow faster. You might want to do the monokaryon thing. But I think if you're just trying to get something new, you can do something simple, just like literally like taking 2 spore prints and getting a cotton bud, a sterile cotton bud, and just taking those spores from the 2 different prints and just swapping them together on the same plate. I love the idea of doing that and then just using the multi-spore plate. So making spawn from one of these multi-spore germination plates. So like I did here with this one earlier, I just literally took a bunch of spores from this MVP and I just smeared them on the plate. And then I took a big chunk, which might have 20 or 30 different dicaryons in it. And I'm just going to make spawn out of that. And then when I grow the spawn and make the fruit, I may see something different pop up. It may all look very similar, you know, especially with something like MVP. It's probably been inbred and stabilized and grown for quite a while. So you're probably not going to see a whole lot of variation. But yeah, it'll be something cool. Something else I should note real quickly here before I forget is that when I get to this Punnett square thing down here, I want to show you guys. I don't know if you remember biology from the 9th grade or the 10th grade or whatever grade you had it in, but you got to remember that when you do the first generation, and again, people have different terminology for this, but when you do the first generation, you're going to essentially not see much variation. So it's usually in the next generation. Maybe I'll try to draw that. I thought I had a diagram of that here. But you can remember these old Punnett square things. Again, I don't know if we want to get into that much detail. But the idea is that statistically, if you're taking two things and you're mixing them together, that first generation, what we call the F1, or what most people call the F1, for some reason, there are people that call it the F0, and I don't know why. And again, that's something you can get into a lengthy debate with lots of people about. Well, not lots of people, a couple people, but for some reason insist on calling that first cross. They call it the F0. And I know why they do that. It comes from, it's a carryover from fish breeding. When you, and snake breeding, if you isolate a wild population of fish or snakes or whatever, and you call that the F0. But for some reason they've carried that over. It's called the F1. Every other biologist calls it the F1, but for some reason there's people in the mushroom community that call it the F0, and I don't know why. But yeah, I've had my discussions with them, and I don't think I ever will again because. But yeah, if you want to go back into the, if you want to go look back in your, your biology book from high school or online or whatever, you can get into a lot of detail and a lot of nitty gritty about these, what they're called Punnett squares. And you can talk about other things like back crossing and all kinds of other really detailed stuff about genetics. Like I said, things like codominance and pleiotropy and all kinds of other stuff, but I don't think we need to get into that. Let me take a look at the questions here real quick before I think start with this slide here. Okay, so let's see. We got questions like cool. I guess it is. Let's see where we're going. See, let's see, no rush, I'll stay. So Vincent, I'll stay off the tangent. It's just that I'm more interested in mycology than I am in growing breeding work. And we were talking about my screen, kind of excited. Sorry. I'll stop asking questions too and let the teacher teach. You guys can ask any questions you want. Again, I'm not at this point in the presentation. I really, really wish I could talk to you guys in person because I know there must be things, and I'm not maybe picking up on the intricacies of the way the reading text questions. So I say why? Well, I say here we go. Why is the blob mutation so common? It's not that common, I don't think. Michael Miner, is that you, Andrew? I forgot. Are you the? I don't think it's that common. It's that people propagated it a lot because it was different. People, so the Enigma thing, I don't know about in other gourmets. I have isolated probably 2 or 3 blobs from other things. I think I isolated I had a GT blob one time and I didn't know what it was. This was like 10 years ago. And I just threw away the monotub because I thought it was just some weird contaminant. I don't think the blob mutations are that common. I think it's just that they get propagated by people. Because there was some folklore that like some of these like enigma blobs, they can't be propagated by spores. So it became this sort of like club kind of thing. If you knew somebody who had an enigma mutation, like you were kind of cool because it's kind of like an autograph. You know, you got like an autograph from some rock star. It's like, ooh, I got that enigma from this person. And it was a way almost to like advertise, I think, certain little cliques in the mycology world. Like if you had that enigma, you were down, you know, you were a cool kid. I don't know how common they are. I know they will. It oftentimes, the times I've got blobs is when a normal culture, if you put it at super high humidity and high CO2, there seems to be something that happens genetically that induces that blob mutation, and I don't know what it is. I don't think anybody really knows. But I don't know if they're that common really. I think it's just that they get talked about a lot and they get shared a lot, I think is the main thing. And because they're, I don't know, they got this sort of folklore associated with them that they tend to be stronger. The real reason why they're stronger is because you grow them for like twice as long. So an enigma or something like a tattoo or a CKB, you need to fruit it in order for the coral or the blob or whatever to get fully mature. You usually grow them for 60 or 70 days, which is like twice as long as a normal culture will fruit, and you get the mushrooms. And if you didn't harvest the mushrooms, they just throw spores everywhere and they'll just start to decay. So you usually harvest, normal fruit after say 25 days. Whereas like enigma or CKB, you get like more like 50 or 60 days. So it gives more time for those alkaloids to accumulate. And because they look weird, I think a lot of people get the impression that, and also maybe the flesh is a little more dense. So people see it and they kind of think it looks like it's really super blue, and it's almost like a sort of a placebo effect, I think, for some people. And also maybe the weight is not, people don't tend to like keep track. Like a lot of people just kind of eat stuff and they don't really weigh it. So they like per volume, it looks like it's not very much maybe. But by weight, it's probably about the same potency as a normal fruit. But I don't know. I don't have an HPLC machine, and I don't have, but yeah, I'm not sure really how super common they are. But yeah, I know you had that blob, Andrew, right? So I guess you are, Michael. Yes, I'm working on a gold one too. Let's go would be worth this week. Yeah, I've never seen a blob. I've never seen a blob in a gourmet, but I don't grow a lot of gourmets, so yeah, that might be an interesting thing. But as long as you don't get kicked off YouTube, Andrew, or Facebook or Instagram, they're gonna think it's something else. Oh, a sporeless gold would be worth its weight. Yeah, I don't know. Are people gonna really eat something that looks like that? I was wondering. I don't know. They look kind of scary. I think I saw a couple pictures of that blob. What do you call them? Moon pearls. I don't know. Are people going to eat that kind of thing? I don't know. Maybe. I don't know. Let's see. It's one of the reasons I like to melt this part. Yeah, I guess you guys are right. Now I understand where you're coming from with that. Like, what's the reason of isolate monos? Because I remember this was a big discussion before too. Like, why would you, if you're isolating for things that just grow faster, like what's the point in getting monos? Yeah, I think that's something that might be unique to the medicinal, like the cubensis market in particular, is people want to grow things that look different. I don't know if the average grower, once they're past their third or fourth monotubs, they probably aren't super interested in yield anymore. I think that's why a lot of the exotic markets do quite well. Some of the newer species that people have brought back from like Mexico and things like that, I think they're getting quite, it's hard to tell whether they're popular or not. You hear people talking a lot about them, like the Cerulescens and the Zapaticorum and things like that. I don't know how popular they are. But it's one of those things too. The people that grow them are quite vocal because they are maybe the people who are selling them or selling the spores, and they're also the people that kind of want to show that they're on the leading edge of that type of mycology. So they tend to talk about them a lot. If you grow a new species, of course you're going to be proud of it and you want to talk about it a lot. Or if you get some weird blob mutation, yeah, you talk about it a lot. I'm not really sure how many people actually grow those kind of things. I know it's not that many really. I don't even know if a lot of people grow, without, I don't know, probably giving too much away, but where I'm at right now, nobody knows like what a blob is. The average consumer doesn't know what a blob is. They don't know what Enigma is. They don't know what CKB is. If they were to see it, they'd probably be kind of turned off by it because it doesn't look like normal to them and they want normal stuff. So I don't know, as breeders and mushroom growers, I think we find that kind of stuff quite fascinating, but I think the average consumer probably would be kind of freaked out by them, but I don't know, who knows? So yeah, I guess if you're looking for aggressive strains and stuff, that's what I was thinking about while I was outside too, is that I think it would probably just simple double swabbing would be like just literally taking two different types of spores and streaking them on a plate and growing them out and seeing what you get. If you're not too worried about what do they call that? The provenance, like where it comes from. If you isolate something that grows aggressively and it looks different, it kind of doesn't matter what the genetic lineage of it is. And I think probably a lot of even the Cubensis strains that people come out with, I know for a fact a lot of the people that are growing Paniolus now, they're essentially doing multi-spore germinations, and they're isolating what they think are monokaryons, and then they're supposedly mixing those with other monokaryons, but in fact what they're doing, they're just doing a daimon, maybe at the best. What they're probably doing is they're just isolating a new dikaryon from one of the things that they thought that they're multi-spore, and they did the grab and drag or whatever, and they isolated what they thought was a monokaryon, but in fact is a dikaryon. So when they do the daimon cross or whatever, they think it's a mon cross. What they're actually doing is just growing out another dikaryon from one of the parents of that supposed cross, and it looks slightly different. And because Paniolus don't have that much phenotypic variation, they think if it's a little bit bigger or something, it's a different thing that they've had a successful cross. But I know some of the people that supposedly did these mon cross, 2 months later, they're like, well, I just heard one of them talking about it last week. Like, well, my monokaryon plate like got a fruit on it. And it's like, well, so their original, what was supposedly a mon cross was actually just a dikaryon that they thought they had bred with another mono. And like I said, at best, it was a daimon. It was probably just a re-isolation of the original strain. So that's always a possibility, and a very likely possibility that if you take a plate, and then you do, you do the XXX thing, and then you do the YYY thing or whatever, do a tic-tac thing, there's a very, very good possibility, in fact, probably a better possibility that you're just going to re-isolate a new isolate of one of the parents. But, if it produces well and it looks different and you want to give it a name, you went back to spores. So at the end of the day, most people, aren't going to bother you if you went back to spores and you re-isolated something, especially if you attempted a cross. It's a strain, it's an isolate. And this is one of those big points of contention. Like, say I get a new MVP. It's like, can I rename it? Can I call it, Ed's MVP or, MVD or whatever, NVP? I don't know. It's up to you. It depends on, I don't know what type of marketing you do and how different it looks. I don't know. It's one of those things people go back and forth all the time. It's like, if you grow a pepper from seeds, can you call it your, East Tennessee Carolina Reaper or whatever? Or do you need to actually like cross that Carolina Reaper with, I don't know, a Trinidad Scorpion or something before you can call it a new thing? I don't know. It's up to the person, I guess. So let's see. Yeah, that's what I was thinking about. Serial dilution, get a few spores per PF Tech jar to select for slower. But yeah, that's another strategy, Vincent, that people used to do. They would really dilute down the spores. So they would take they would get a multi-spore syringe and they would either, just shoot a very, very tiny amount in, or they would dilute the spores so that you're essentially, you're doing a serial dilution with your original spore syringe. I don't know, I guess there's lots of different ways you can skin a cat, as they say. But yeah, again, for the blobs need to do a diamond to breathe them, right? Yeah, so Vincent, there's a good question. So that's kind of funny because probably the main reason I started to do breeding was to be able to do diamonds with blobs. So I have a bunch of crosses. It's kind of funny because I don't have an Enigma culture anymore. I had 2, but I was kind of neglecting them. But I do have a bunch of diamonds that I did with Enigma and like an iceberg, and Enigma with a Hawaiian, and Enigma with some other Tailepai and all these other things, and some CKBs. And I don't have the original CKB or the Enigma. But yeah, that's one of the things you can do, and that's the reason I did it. So that actually is a good point, because this is the slide we're on now. So this is a little bit different. I was trying to find a slide that would isolate a dikaryon, a diploid, and a haploid. So if you guys don't know, we use this terminology here, this kind of N indicates a haploid. That's like one set of chromosomes. So that's what these 3 things here, they represent chromosomes. So in this organism, they have some fictitious organism. It has 3 chromosomes. So in, say, like a sperm, it would have 3, and an egg, it would have 3. And then when they come together in things like humans, they match up, and then you get what's called a diploid. Well, fungi are a little bit different in that they don't combine immediately. So instead of having these nuclei from the 2 parents fused together to form the diploid, which they would do immediately, like say in a human or a plant, they remain separate. And so you end up with what's called a dikaryon. So we represent by writing N plus N. And so this is what we mean by dikaryon. So when we say a diamond cross, we mean, oops, I'm going to mess up so it's called a dikaryon. And so we can utilize that fact. And that's where we're going here with the next bit of the presentation, is that we can use this in what's called a diamond cross. So let me make sure. So blobs, you need a diamond cross. Chef, love it. Can we talk about specific breeding techniques and how to do them? I'd like to learn how to put this into practice. Yep, that's where we're going right now, Strand Farmer. We can skip the microbe thing here. So if you want to get, let's see, got a blank drawing slide. So what you're going to do, can you, before I go off on a tangent, Strand Farmer, can you tell me which technique you want me to talk about? Because I kind of talked about all of them, but I'll draw them out. So can you tell me what specifically you want me to talk about? Because there was a bunch of them, and I kind of talked about all of them in various forms. So if we go back here, can you tell me which one you'd like all of these things? Can you tell me which one, which one would you like me to talk about first? Because I think we talked about monokaryons quite a bit already. So there's, that's pretty much all of those things. Can you tell me which one you want to talk about specifically. Okay, so man. So man. So again, we're going to assume that you have a culture. Let's see. Yeah, that's what Andrew's saying there. I'm not sure what you mean because I kind of talked about all this stuff in various forms already. So if you have let's say you have a monokaryon culture here. So we'll call this N. So this is your culture on a plate. And here's another plate. And this is going to be your mono. So you have two monokaryon cultures. Right. So you got two of these. So the idea is you're going to take these and you're going to put them on a new plate. So you're going to cut out a little piece here and you're going to place it on the plate there. And you cut off your little piece here and you put it there. All right. So now you've got two little pieces on here. Right. So there's going to be your new inoculants. And so this is on a new petri dish, right? So you have your original petri dishes here. And you know, that's all covered there. Right. So you take those two pieces and what's going to happen as these start to grow out here, they're going to come together and there's going to be a line. Let me draw this a little bit bigger. So you're going to get these little inoculation points that they're going to come. There's, and then your other one over here. So they're going to grow everywhere. But so as you get this little interface here, okay, so remember, this is going to be your N and your N. All right, so this is where we call this a mon, right? Because these are two monokaryons. All right, so again, I don't think we need to go back. There's lots of ways you can get monokaryons, but this is assuming that you have two monokaryon cultures. They are verified as monokaryons. You put the two ends on a plate. So your two little chunks of agar from your monokaryons, you let them grow together. That might take 5 or 6 days. You probably want to put them about maybe a ½ an inch apart, you know, centimeter or so. The closer you put them together, the faster they're going to meet with each other. And hopefully from this little piece right here, you will get N plus N. All right, that's if they're compatible, which is something I don't think we need to go into. Let's just assume that they are going to mate with each other. So now you have what's called a dikaryon. Okay, so what you can do multiple things here. What I like to do is I like to take this whole big chunk and I cut it out and I make spawn out of it. Because you have to assume that if it made the dikaryon right there, when these other pieces of monokaryotic mycelium meet the other monokaryon, they are also going to mate. And you will end up with one big old culture that's N plus N, which is a new dikaryon. So if you have a culture of oyster mushrooms or whatever, the normal kind of culture that you grew, that you bought from Andrew or wherever you got it, maybe you cloned it from a mushroom, that is a dikaryon. Right, that is the standard state of all mushroom cultures, is what we call a dikaryon. Okay, so you can take this little piece, and if you want to be real fancy, you take this little piece and you cut it out and you put it onto a new plate, and now you have your N plus N, and you can say, look, I breeded, I did a mon, and there's my dikaryon, and then you can send it to all your friends and grow it, and all the world is your oyster. Well, that's actually just the beginning of this process. So, gosh, I just realized I wish I knew how to erase this because I don't have another slide to draw on. So you grow that out and then you get your mushrooms. And what you'll notice, so this is what we call the F1. Okay, so this kind of combination here, When it makes spores and you produce fruit, you call those the F1, right? This would be like in the old Punnett square down here kind of thing. Let's see, one of these that you might remember from biology in high school. So what has happened here, though, is you've only taken one of these. So here's where the interesting thing comes in. Like you guys were talking about, if you have, say, a recessive trait here and a recessive trait, so these would represent your spores, right? There's the N of one and another N. And so if you were looking for a recessive trait or something that was kind of weird, like, say, slow growing, in that combination, you would have this N plus N that has two recessive traits, and you could get, say, something like albinism, an albino mushroom. Whereas, say, one of those things was a big R, the dominant trait, you would get something like either, you get this one right here, and that's going to be what we call heterologous. Or heterozygous, rather, not heterologous, heterozygous, where you have one dominant and one recessive. And in that case, you're probably just going to see something that looks more normal. And you can't really predict this. It's just, you could, I suppose, if you had some pretty sophisticated genetic, like kind of fingerprinting technique, but I don't think any of us out there or in the audience or me has that ability or that desire, because it would be quite expensive and time consuming. If you were, say, a seed company, and you were producing soybeans or corn that you were going to make a lot of money off of, you may go through the process and the money, the investment of doing that type of work. There's things we call quantitative trait loci, or QTLs. You can actually do that work, and you can kind of identify which of these traits are associated with, which of your isolates. And that's what they do in like the soybean industry and things like that. But we're not, we're not making that much money. So you could go through all that. So now you got this dikaryon thing here, and you're going to try to fruit it. Where did that go? So you're going to try to fruit this thing. And then you get your mushrooms, and then you get your spores again. Now, those spores in that next generation, what we call the F2, that's where you're going to see your variation. So here's something that maybe a lot of people don't really quite understand, is that this is just the first step. The first step is making this mon cross and then making those fruit. And the important thing comes when you get the spores from those fruit, and then you grow those again. That's where you see your generation. So here's where the terminology with mushroom kind of breaks down a little bit, because technically the F2 generation is not until you get the spores, but it's one of these just kind of terminology things. There's a little bit of a disjunct in the way normal organisms reproduce in the terminology, what we call F2 and F1. But the idea is that in that next generation, you're going to get those two original parent nuclei, that N plus N, they're going to recombine, and they're going to make new variations. And so the only way to get that variation is to put that N plus N dikaryon into fruit and force it to produce spores. And so the fruit you see in that F1 cross, they're going to look pretty generic, because it's the nuclei they haven't quite, the fruit that were derived from the two parents, they're not going to be, they're kind of just like a mishmash of both of them. And you're not going to see anything in particularly special. It's when you go into the next generation and you actually germinate the spores from that fruit, that's where you'll see all the cool things pop out, like the albinos and different mutations. So I wish there was a way I could erase this. I know there is an eraser thing, or a way I could like undo or something. I don't know. Let me try an eraser. Oh, here we go. Erase all. There we go. Okay, so hopefully we don't need that again. So, yeah. So let's see. Where was I? So that's a mon. So again, that, as you can imagine, that takes a fair amount of effort. You've got to isolate and verify your monokaryons, and then you got to do all this fancy culture work, and then you got to get spores. So you can see already, this is why mon breeding is it's not very common. It's not common because there's a lot of effort. And if you're going to really get into this, you gotta be really in it for the long haul, because if you just are going to do it halfway, you're not going to see the results. Because it's not the kind of thing you're just looking to see what you're going to get in that first kind of cross. You have to go to the next generation. So you have to really, really take it to that next F2 generation. Otherwise, you're not going to see any of the results of all your hard work. This was something, again, that like I didn't really realize until I heard this guy, Dave Wombat. Maybe some of you guys are familiar. He's like a OG of the magic mushroom world. When he said it during an interview one time, it was like a light bulb went on in my head, because the common problem when people do breeding, even with, it doesn't matter what type of technique you use, when you mix two spores together, whether it be multi-spore, whether it's mon, daimon, whatever it might be, you'll often see in that first generation, you won't see a whole lot of variation in the fruit. And sometimes it's quite disappointing, because, you know, you think you get all excited and you're like, wow, I got these spores from two mushrooms and I'm mixing them together and I'm going to isolate me a new thing, give it a name. And then you grow that fruit and you realize it all pretty much looks the same. When you look back at your 10th grade biology book and you see those Punnett squares and you see the Mendelian genetics, then it all makes sense. And I might as well just go through that right now, because if it, let's see. Let me read the questions here. So before I couldn't find, so here, I want to show you guys here. I want to show you guys something. Here's where the magic, I couldn't find a slide for mushroom breeding that illustrated this, so I'll just draw it. I had it drawn on one of the old videos that was on YouTube. I went through this. I've made like a 20-minute video and went through this, but I can do it right now. Let me see, TT, mon, maybe Daimon. I'll come back to the Daimon in a second here. Strand Farmer. Remind me if I forget to come back to the Daimon thing. Just interface it to the pro. So yeah, Vincent, here's another misconception. People for some reason tend to think that this dikaryotic state propagates itself back over. So yeah, a lot of times, so you'll get your chunk here and your chunk here, and then they come together at this interface, and this is where you get your dikaryon. Some people erroneously think that this propagates itself back through the mycelium and that the whole thing becomes dikaryotic, because what you'll often see is you'll see a fruit body like over here, and you're like, well, it must have propagated itself back through the mycelium. If you think about it, that doesn't make sense. The monokaryotic, so these were haploid mycelium, they didn't become dikaryotic. The reason why, if you look closely, you'll see those dikaryotic mycelium, they grow over the monokaryon, but the dikaryotic state doesn't propagate itself through the pre-existing monokaryotic mycelium. That doesn't make any sense. I've heard that said over and over and over again, that, well, it's not like, you know, Avatar or something where, oh, you like touch two tails and they become, all of a sudden the whole thing becomes dikaryotic. That doesn't make sense. No, the nuclei don't like transfer. And I've even seen it in older literature. They sometimes, it's like the way they word it, you would think that that's what they meant, but it's not what they're like. I think it's a misreading of some of the earlier literature. I mean, early like 1920 kind of literature. But no, I mean, unless there's some magical process that where I don't think, they're not slime molds, like xenocytic slime molds. Yeah, they're multinucleate. They have cytoplasm that moves amongst the cells, but basidiomycetes don't do that. And I don't know why people think that. You don't, because you need a clamp connection most of the time also for the dikaryotic state to propagate itself. So I don't know. Can't conceive of some mechanism of how that second nuclei would somehow propagate itself to the other side of the plate. No, it's the dikaryotic mycelium, the new de novo, you know, mycelium. That's what propagates itself. And that's why you'll see fruit bodies on the edges of the plate, like over there too. So I don't know. Again, that's something like one of those old wives' tales. I think that was said and then got propagated. And I know where it comes from. I've read the literature where it comes from, and I think it's a misreading of or they just kind of misstated it. So I guess I have a better chance. What part does epigenetic play? Yeah, Michael Miner, can we wait to get that? I'm not sure what epigenetics do you mean? Like what part of epigenetics? There's a bunch of epigenetic stuff that I could talk about that is actually illustrated in this slide pretty well here. This slide. This is a photo from that was it Nieuwenhuis book? This slide is enormously complicated. It looks really simple, but can we talk about that a little bit later? Let me explain the daimon thing real quick because I want to get distracted. Actually, let me do a Punnett square real quick here because I want to make sure. I think this is like quite important. So let's say, so the basic idea here is that let's go old school, and let's say you have two true breeding strains, and let's just go like with the traditional example here. So the only way, so you take this one, and you get a T and a small t, big T, small t. You take this one, and you get a T and a big small t, big C, blah, blah, blah. So the point is here, you get 4 big T, little t's. Okay, so this is why in the F1, you don't see any variation in the fruit, really. So when you take those spores from your initial cross, or your culture from your initial cross, and you've got this, these gametes that have come together, they undergo meiosis, you don't see really much variation because they're all basically the same. They're what we call heterozygous in this case. So they got kind of a mixture. This is like simplifying it quite a bit, but you essentially don't see much in that first generation. So what you have to do is go to the F2, which again, if you go back to your old biology book, this is what makes perfect sense because, sorry guys, it's really, really sloppy here. Because if you mate these together, you'll have your gametes are going to be this and this. And here's where you'll get your TT, your big T, small t, a big T, small t, and here, small t, small t. That's the one you're looking for, right? You're looking for that, what's called a homozygous recessive. This is where the weird mutations pop out. And this is why you need to go to the F2. If you just stop at that first generation, you do your mon cross or your daimon cross or whatever it might be. If you stop at your F1 and you just look at the fruit, you're going to be like, well, that wasn't successful. Doesn't look like anything special. You stop, waste of time. You got to get the spores from that F1 and regrow them. So you go back and you do exactly the same thing. You take the spores from the F1, you put them on an agar plate, you do a multi-spore. That's probably the best way to do it. Or you could isolate single dicaryons from your multi-spore, however you want to do it. Make a multi-spore syringe, do a BRF cake or whatever. But you got to go to this F2. You got to go to that second filial generation. Otherwise, all that effort was pretty much wasted. So again, I could go through that in more detail, but I probably confused the shit out of you guys already. So that's a Punnett square, by the way. If you go back to your biology book, it'll explain all that intricacies to you, but it doesn't have any relevance to anybody, including myself, until you start thinking about it and you start doing this and you're like, wait a minute, I'm not really seeing any, like I did so many mon crosses and I was getting disappointed because I'm like, I am not really seeing anything interesting. And then Dave Wombat, he said that in like a really brief offhand comment one day in an interview, and I'm like, oh my God, oh, that's what, okay. And it's like the light bulb went off. And so if you're looking for albinos or anything weird, you could get them, on like a numbers game. But if you're doing the mon thing, especially, you got to go to the F2. So that's the mon thing. Remind me to come back to the epigenetics, Andrew, because I'm not sure what part of epigenetics. Let me explain. I should have put an extra slide in here. Let me erase. Yeah. So nobody has any questions on that. This is one of those things. I'm going to erase it. Do I got another blank slide in here? Blank slide. I know I put 2 or 3 in here. Let's see. Blank. There we go. Okay. So what's a daimon? Daimon. Here's where that epigenetic things might come in. And I think I might know where you're going with this, Andrew. You gotta think about what the donor is and what the acceptor. So who's going to be the mother and who's going to be the father? What's the paternal and maternal lineage? So you, as I'm sure you're aware, Andrew, the mitochondria is going to live with the mother. Okay, so what do we mean by mother? Because we already said that both they're isogamous, i.e. the spores are the same shape. We can't distinguish between a male and a female, or the mother and the father. So what the hell am I talking about when I'm talking about maternal lineages? Well, one of them has to be the acceptor. So we don't necessarily need to call it a mother, but we might as well for convenience. In the kind of human paradigm or whatever, analogous situation, the mother is going to be the one who basically has the egg. In a mammal, the egg is what has all the mitochondria. And that's where a lot of the epigenetics comes in. So epigenetics literally means like above genetics. So we have 2 types of genetic components, at least 2 types of genetic components in every single mycelial culture. We have the nuclear component, which is in the nucleus. And then we have some other random little like small nuclear DNAs, we call them. But the other main one is in the mitochondria. So when we're doing like a mon or a daimon, we got to figure a little bit sometimes which one is going to accept this nuclei. So in a mon, it's a little bit tricky to figure that out because you don't really know unless you had some pretty fancy microscopy which nuclei is going to be transferred to which mycelium, right? So if you got mycelium 1 who's going to be the mother, then that's going to accept a nucleus from mycelium 2. And so in that case, you would probably call her the mother, and that's where the mitochondrial DNA is going to reside. And so the number 1 fungus is going to have much more of an effect because of these epigenetic elements like the mitochondria. The mitochondria is what generates all the energy for the cell, right? It's where all the like sugar metabolism and all the energy, the ATP, all that jazz, all that stuff comes from. So if you were being really, really, really kind of meticulous about, doing a breeding program, you'd probably want to figure out some way to use a maternal strain that had higher growth characteristics. Again, I don't know how you would do this and how you would manipulate the fungus. One of the ways might be through a daimon, and I'm a little bit too tired to be going through that in my brain right now, but you'd have to figure out a way to force one of them into being the mitochondrial donor. And that might be by using a monokaryon. Okay, so let me explain that now. Let's see here. I'm gonna parties. Let's see. So let's see. So let's explain the daimon. So here's the idea. With a dikaryon, you have 2 nuclei here, and I would make them different colors, but that's gonna be complicated. I keep changing my pen. So here's the idea, right? Dikaryon, monokaryon, N plus N and N. So the idea here is that you're going to get one of 2 new possibilities. You are going to, there's multiple possibilities like it showed on that figure from his book. You've got two N's here and you got 1 there. So potentially the idea is that one of these N's is going to donate itself to the monokaryon. So in that sense, the monokaryon is going to be the mother. And so the N is going to kind of be like the sperm that donates, its genetic component to the egg. And so the mitochondria is going to be inside of this monokaryon. The other possibility is the second nuclei from that dikaryon is going to donate itself to the monokaryon. So you have two possibilities. But if you look back there, I don't want to find that slide again, but there's another kind of possibility in that you could have kind of like a conjugal exchange of nuclei. And then there's, you know, possibly this nucleus could come over here and one of these could leave. There's other people that have speculated that this thing could de-dikaryotize and maybe become a monokaryon, and that the dikaryon itself could become individual gametes. There's different ways, and a lot of people have speculated about this. Again, it's fungus. We don't really know what the hell's going on. And like I said, there's not enough interest for somebody to track these nuclei. There are ways to do it, but you'd have to do like some pretty fancy genetic stuff. You'd have to figure out how to label the nuclei somehow without affecting their viability and all kinds of other stuff. Anyway, that's for Mr. Nawenhouse to do. I wouldn't ever try to pretend to know how to do any of that stuff. I'm sure there must be a way though, or like cracking the QTLs like they do in soybeans. But that costs like millions and millions of dollars, and you know, we're not going to do that stuff. So essentially that's a daimon. So the idea here is that you generate a new dikaryon that's either a combination of that monokaryon and one of those two nuclei. So if, say, this were a blob, if your dikaryon was a blob, it doesn't produce spores. If you wanted to mate that with something else, this would necessitate you using a monokaryon. So there's another myth that constantly floats around, and I can crush it right now, and I wish the people that keep saying this would stop. There's this myth that you can take two dikaryons and put them together and they will mate with each other and exchange your nuclei. That is probably one of the stupidest things I've heard, but it keeps going around in the... And it's funny, somebody actually took my old videos and made an AI bot of me, and it was, the example I used was like, if you see two cats rubbing against each other in a room, like, do either of those cats get pregnant and make babies? No. Like, so it's a slightly different scenario. I mean, in fungi, because technically cats are both diploid and the nuclei have already fused. So it's not a perfect analogy, but there might be some, there is in fact a patent published that was based on a dikaryon mating. As far as I know, nobody's ever actually done that, but they've been talking about it for years. There's another variation on the blender tech, which a couple guys are proponents of, that say basically you take two dikaryons and throw them in a blender and they'll mix with each other and make new combinations. At that point, you're essentially doing like a multi-spore breeding. So I don't know why you wouldn't just do multi-spore. But if it were, say, two blobs that you wanted to breed together, or you wanted to breed a blob with some other dikaryon, I mean, I don't know, whatever, you know, people can do whatever they want. I wouldn't waste my time trying to do die breeding, but you know, whatever. People can do what they want. So that's where the epigenetic thing comes in. And this is where, yeah, like which one of those is becoming the mother, or, you know, I guess performing the role as the mother, and which one is the father. So let's see, do we got any questions here? There's other epigenetic elements. There's viruses, there's transposons, there are probably other genetic elements in the cytoplasm that could be transmitted. Yeah, there's a lot of other things. So yeah, let me go back to your question here. So that's another reason it's probably better to use mon versus a getter swabbing. I'm not sure what the other reason is you're talking to, Vincent. Sorry, I got a bunch of thoughts going through my head. It's kind of hard to, I'm not sure what you're referring to. You know, you do have a new strain, and you know it's worth going to F2 to find out. Yeah, Vincent, so everybody seems to think, I think probably because there was a couple of videos where I think one of the videos was labeled something like Ed Grand is the mono king or something like that. Yeah, I got like half the Myco community pretty much hates me. I don't know if you guys figured that out, but a lot of people don't like me, probably because I'm some arrogant, educated prick or something. I try not to be like that. I'm not really, that's the thing. I'm not really a proponent of doing mons. In fact, if I were a gourmet farmer, I would just be doing multi-spore. I would be collecting spores, and I would just be like shooting spore syringes into every possible bag. I don't know, like I would just be doing a bunch of multi-spore and doing pheno hunting. But I would definitely be going back to spores a lot. I don't think people in the gourmet world, regardless of whether they are trying to breed or whatever, I don't know, they just don't go back to spores. I mean, a lot of people, even in the the magic world, they don't go back to spores. People are getting so used to using LC now. So I think there could be a big advantage in the sense that if you could make new strains, they could be very potentially, I don't know, good sellers. The problem is, like everything, it doesn't matter if it's new plants or new orchids or I don't know, anything you can propagate clonally, you can very quickly replicate it and resell it. So if you do find something unique, I'm actually working on stuff now, and I'm done sharing my genetics. I made my contribution to the world, and I kind of, I think I'm done, because I know as soon as I share the things that I'm working on now, they'll immediately be like bastardized and distributed freely. And well, not freely, other people will sell them. So the only reason I sold genetics before was because I hadn't done the pheno hunting. Now a lot of the stuff I'm working with is clones that I've fruited multiple times, and that I know they've got a good track record, and I know that they produce quality. There's some animals outside my window. It's like 4:30 in the morning here. The animals are waking up. Yeah, I know they produce well, so I'm not going to share them anymore, because I've not only gone through the process of breeding them via diamons or monmons, but I've also tested them. So that's where the real work starts. I mean, as you guys probably know, it's a lot of work to grow mushrooms, and it's a lot more work to breed mushrooms and then pheno hunt and test them. And so I'm at the point now where I'm not gonna share my genetics with anybody anymore. It's not because I'm trying to gatekeep or whatever. Everybody knows how to do this. It's just whether they're willing to put the effort into, and whether most people just want some LC and they want to grow some mushrooms. That's fine. They can go buy that for $10 or whatever. But I'm not going to share the work that I've done after you've gone through months and months or years of developing these strains. And then I'm sure Andrew knows very well about this, and then you send it out to somebody and you see it on a website for, a fifth of the price next month. It gets kind of disheartening. Oh, cool, Vincent. Thanks. I'm glad that made sense. Yeah, it's one of those things. It kind of, if you go back and you look at your bio textbook, you're like, oh yeah, oh duh. Like it's the famous, like there's a famous diagram in most textbooks, and why it's really the reason why Mendel is so, and he's the father of genetics, is because he was the one who went through all this effort. That poor guy, literally, he bred like tens of thousands, if not hundreds of thousands of plants. And he looked at the phenotypes. I mean, he did this for, I think it was about 7 years. You know, he was some kind of monk living in a monastery. I guess he didn't have much else to do, but that's the thing. People don't realize how much effort it takes to generate these new strains. One of my old students, his dad was an orchid breeder. And he said the same thing happened. His dad worked for like 10 years developing this orchid strain cross, and somebody just stole it from him. Somebody like snuck in, and literally like people will break into your house. It's kind of funny where I live now. It's not like nobody really steals anything, but it's getting to the point now where I'm not worried about my motorcycle or my computer. I'm worried about the cultures that I have in my house, because I know somebody who wants them very badly. And it's like, I wouldn't put it beyond this person to like literally break into my house to steal agar plates. Anyway, that's a side note. Let's see. Let me get the question, explanation. I get so much hate too, man. Yeah, I know it sucks, man. The hate. That's why I always warn people. Like, you think the mushroom world, some happy-go-lucky, a bunch of hippies. Like, no, that helps. You're my favorite mushroom people. Leasing is where I'm heading with the genetics. I'm not sure what do you mean leasing, but just having terms and conditions on my site has made it. Oh, stop taking my new stuff. Oh yeah. I hope that works out for you, Andrew. I don't know how you're gonna control that, to be honest, without getting a bunch of lawyers involved and stuff like that. Yeah, even with the, I mean, gosh, we could talk about this later, but with the sequencing, I don't know if how you're gonna be able to prove proprietary, like intellectual property, even with sequencing. I don't know how that's going to work out. I mean, it might just be the threat of you doing it might be enough, but it's going to be really difficult to prove even with full genome sequencing. I think that you have something that unique or somebody else copied. There's another way you could do it. We could talk about it later. I was going to talk about it on a couple episodes with of a podcast. What is it? It's called like fingerprinting, but it's not the fingerprinting like they do on the, like not the ITS. It's like what they call short tandem repeats, STRs. They have a couple different versions of them. They call them ISSRs, or these what they call sometimes called SNPs, SNPs. It's kind of the way they do the heritage testing, the genetic lineage things, like on 23andMe and stuff like that. They don't do full sequencing just because it's impractical, but there's other ways. But there's a few things about it that might not really work for mushrooms, but. Right, I'm probably not doable with actives though. Mendel has lucky picked his piece because he confused a plant with a polypropylene. So confused when he hit a plant with poly. Oh yeah. That's polypropylene. That's for Vincent. Like our culture world is far different than a mushroom world. It's crazy. Where to put the cell frequent in the contract? Yeah, we can talk about it later, I think, Andrew, because I'm not sure how doable that kind of thing is going to be. With like some of those companies, they put tags in the DNA, so they actually went in and put very unique tags like in their DNA sequences. Like, so if they have a plant that has some sort of a plasmid in it that they've engineered, maybe it has like the BT toxin or something in it, they can actually put like extremely unique DNA sequences that would not occur in the natural DNA. Like they'll put like 50 Gs in a row, or 50 Gs and then 100 Ts and then 50 As, and like something like that would never occur in nature. So it would be obvious that if somebody else was using it, it would be like a very distinctive and also easy to test for kind of thing. But two naturally occurring strains, the genetic variability in them naturally, I think would be enough for a person to say, like, look at this variation, it's not exactly the same. And then you'd get down to the kind of numbers game, like what happened with Natalensis and Ocrasio centrata. Yeah, it's a mess. It'd get really nerdy really quick. So let's see, guys. I think we got an hour. How about I wanted to there's a really good guy, some good stuff. Somebody was talking about the milky mushroom. This guy on Facebook, I don't know, he's from India, and he is using AI or what, I don't know, or she. And some of these things, they're really small, I know. But if you guys see these, take a look at some of them. I've been reposting them. The guy is Micro Fungi, the mushroom expert. He's got these really kind of infomatic graphs, whatever you call them. Yeah, been helping me out. They're not, I mean, they're very generic, probably stuff you guys already know. But anyway, if you see that guy, mutagens, let's see, talk about mutagens for a while. If you guys got any questions, let's see. I got two if you need them. Mutagens, I don't know. I think Andrew is using the UV EMS. Fluconazole is one that I've been trying to use, but I haven't got around to yet. Colchicine for polyploidy. And then again, we're back to this idea of naming new things. I guess technically you can name anything you want, but then the cannabis world is full of names, and the magic mushroom world is full of names, and I'm sure the oyster mushroom. I know there are some cultures here. I think they were Andrews that people are using, and they gave them slightly different names too, but I'm pretty sure they didn't come up with anything new. If anything, they might have went back to spores and just did a new generation, but I don't think they probably did any actual breeding work. I know probably one of the guys who runs the company. I don't think he's much of a mushroom breeder. But yeah, like you're saying, Andrew, the kill curve on the UV. I haven't actually used, I'm kind of a little bit frightened to use UV because I used to work in a hood that had UV in it, and I always used to forget to turn off the light when I started working in it. It was an older hood, and it wasn't one of those safety ones where like you turn on the visible light and the UV automatically goes off. Like you could turn on both the UV and the visible light at the same time. Maybe that's why I got all these brown spots all over my forearms. But yeah, it probably doesn't help that I ride a motorcycle like 2 hours a day either. But yeah, the nomenclature thing, I don't know. Let's see if I think we talked about the one of the things. Yeah, I wanted to reiterate there. If you have something that you think is a mono and you see like a fruit growing on it, not a mono. Right? So one of the ways people used to test, there's a kind of famous story, a guy who released a monocaryon, and at the time he was selling it for $250. So for a 10 ml syringe of monocaryon liquid culture, he was charging $250, and he sent it out to like 20 people. And about 2 months later, he had the unfortunate kind of announcement that he had to make that monocaryon was a dicaryon because the plates that he had shot it on as like, test plates to test its sterility or its, asepticness were growing fruits on them. And so everybody came up with all these different speculations about how a monocaryon had possibly turned into a dicaryon and homothalism and blah, blah, blah. But the point is that he just didn't check it well enough. So if you are going to do monocaryon work, here's one thing I would suggest that you guys do. If you have, like I do here, like these MVP, if you have two monocaryons and you think they are monocaryons, keep them both separately on a plate and then put them together to see if they'll mate with each other. There's another small problem with monocaryons. I shouldn't say small, it's a big problem. If one of your ends is not a mushroom, okay? So here's another problem. Because monocaryons sometimes look so weird when they grow on plates. I mean, they look horrible. If you want to talk about horrible too, if you ever try getting paniolus monocaryons, they are hideous looking. There's this, you'll hear people say like monocaryons, they grow out sort of radially and they're tomentose and they look kind of wispy, and that's not true. They don't look like anything different from a normal culture. With the exception, like I said, with cubensis, the dicaryons will look rhizomorphic. So you can see here this culture. This is one of the cultures. I think that's actually my photo. You can see here there's a lot of that culture you see around here. It's not really particularly rhizomorphic. A lot of times this is one of those things, especially now I'm growing a lot of cultures. They look very crappy. They look very tomentose, but they're growing mushrooms fine. It's because I changed my media. I'm using gel and gum, and they're growing at probably 5 to 10 degrees warmer than they would normally grow. So they're looking very wispy. Essentially, they're growing too fast. So yeah, that's the kind of one of those myths, and you hear it over and over and over and over again. Let's see, what else do we want to talk about here, guys? One of the Buller. There's Buller. Where is he? There's Mr. Buller. Arthur Henry Reginald Buller. I think this was back in, gosh, the 1890s. As I mentioned before, he figured out that this, I don't know what you would call it, maybe non-reciprocal exchange of nuclei could happen between a dikaryon and a monokaryon. So this is one of the fascinating things about doing multi-spore germinations like the BRF or the PF Tech cakes, is that you can take your multi-spore syringe and you can shoot them into a cake. And like somebody was mentioned, you can make them pretty dilute and you can see various colonies on your cakes where maybe one or maybe two spores have germinated. Maybe they've come together and dicaryotized. Maybe they are still monokaryotic. And you can see this whole brilliant interaction. And so you'll end up getting, so, you'll basically, if you're familiar with the BRF Tech cakes, you take your little cake, you flip it out, and then you put it on a little bed of perlite, and you'll see your little mushrooms growing. Right. And so over here, that mushroom and this mushroom, right, and this mushroom, those are really probably different strains. So you can clone those. So one of these might be an albino. And this is where people found all these albinos. They were going back to spores because spores were legal. They didn't want to get caught with cultures. They didn't have the capability to grow their own cultures. Maybe, it's some kid in a dorm room or something. And, he's got like a steam bath, some kind of bun cooker or a hot dog warmer or something like that. He's sterilizing his BRF, his brown rice flour cakes, and he's shooting spores into them, and those spores germinate, and yeah, you get things like albino. And then, when you get an albino, you're like, hey, maybe I should try to clone that. And then maybe it's too late and it dies. And then, I had multiple albinos that popped up when I was, when I was first getting into this, and, I didn't know what to do with them. I'm just like, oh, that's a weird looking mushroom. Now albinos are sought after by a lot of people. So that's where we sometimes get the Buller phenomenon, or we just call it a daimon. Yeah. And so these words like plasmogamy, karyogamy, anastomosis, again, they sometimes get used a little bit loosely, but yeah, we don't need to go into the technicalities of that. So I'm a big proponent of the daimon. The main reason because how many dicaryons, like it says here, the abundance of dicaryons in the public, right? We've probably all got, I probably have 100 different dicaryons. And so this one MVP mono that I have, that means I can do 100 new crosses with a single. And the MVP is close to my heart because, well, that was the very first mono I accidentally isolated many, many years ago. And so I'm going to take that mono after I check it tomorrow for clamps, and I am going to mate it with a bunch of dicaryons and probably get a whole bunch of new crap that I'll never fruit. So I've got piles of, Hawaiian pearly gates. Oh, I do got a CKB over there. So this is a way you can basically pull out some of the genetics from that dikaryon. It may not be the best, it may be the bad nuclei, it might be the good nuclei, who knows? But anyway, it's just something else to play around with. Like I said, you can get dicaryons, you go to the store and you buy a mushroom and you clone it. Bam, you got a new dikaryon. Also, a lot of people have worked really, really hard It's like you're learning from other people's mistakes. Like why reinvent the wheel? Go get somebody's dicarion from a store, store-bought mushroom, or buy one from somebody, and then get your monos and mate them with that already available dicarion. Again, worst case scenario, you just refruit the original dicarion. So maybe you mix your mono with your dicarion, you're trying to do a daimon, it doesn't work. Worst case scenario, you just get the original mushroom, right? Like I said, there you can coax out the genetics. Yep, like we're talking about with the CKB or some kind of blob thing. Speeding confirmed. There you go. There you go. A confirmed. That's the big thing here. Confirmed monokaryon. So how do we do that? And I think some of these slides maybe should have been in a different order. There is a kind of reiteration of all the breeding techniques. Let me read the comments here for a second. Kill curve on it. Yeah, no, yeah, I'm terrified of UV. Not terrified, but I'm not really keen on working with it. I'll work with deadly chemicals and radiation, but not UV. Once I started working with spores, I started seeing every type of mushroom grow pretty much every version. Yeah, yeah. This thing about the mono characteristics and what they look like on plates, I want to scream every time I hear somebody say that. And it's usually there's like 3 people who constantly say it again and again, and they're 2 of which are total idiots, but the other one, I don't know why they keep saying it. And who there? This is from one of the original videos I made that got taken down. That's it. If you want to know how to breed mushroom, that's it. 7 easy steps. Do a grab and drag, get your monos, subculture your putative monos through you a plate, just like I did. Let them grow out an inch, check for clamps. That's what I'm going to do tomorrow at 400X. And you can double check no fruit on the monokaryons. So get those monokaryons that you've confirmed on the new plates. And then maybe I usually check them. So I check them first before I get them onto a new plate by themselves, so I'm not wasting plates. Second time before I subculture them again onto a new plate, and before I use them in a mating experiment. And then usually every single time I check them before a mating experiment. So I check these monokaryons like again and again and again. Also keep them around. Like some people will say like, well, I had a bunch of monokaryons, but I threw the plates away. That's when you know they're full of shit, because nobody throws away monokaryon plates unless they get old. I have thrown a bunch away, but if you're doing all that work, you don't just casually throw away a monokaryon that you worked or did all that work on you don't just throw it away. Anywho, pair monos with themselves. So as I said there, to make sure they're not contaminated, you have one of the main things, like people will put 2 monos together and they'll say, well, they didn't mate with each other because the mating alleles are the same and blah, blah, the pheromones and the recognition, blah. And then, yeah, the real reason is because one of them was a contaminated. What was a contamination? There is something called Mycelia sterilia. It is sterile mycelium, as the name implies. And it's essentially white mycelium that grows on a plate that never does anything. It doesn't have clamps. It doesn't make spores. It doesn't change colors. It's just some random mycelium growing on a plate. And they are quite common. They're quite common. These things, they just grow. I don't know what they are. Some kind of the anamorph of some ascomycete or something that, some mushroom that's wanting to form, but it's not in the right conditions. Yeah, they're all over the place. When I used to isolate a lot of plant pathogens from leaves and dirt samples and soil, whatever. And yeah, there's tons of them. You get plates of just white mycelium that never does anything. It never makes a fruit body, never changes color, never makes conidia, never makes spores. And they just look like they could be a monokaryon, but they're not. And you put them together with another monokaryon and they don't mate. And you're like, well, that's weird. Maybe they were the same mating type. That does happen. But especially if it's two spores from different cultigens, different strains, or different, like a GT and a B plus, or black pearl and a whatever, different types of oysters, they will mate with each other. And that goes back to that kind of sex thing. The only time when you'll have trouble mating two monokaryons will be if they're from the same exact mushroom. And I can talk about that in a second, maybe if we don't have anything else to talk about. But so yeah, the idea is that you put them together with themselves, and if they do, maybe again you just make a new dikaryon. You don't waste a plate. You just got a backup of whatever you were working with. And again, also check the original grab and drag plate to make sure there's no little fruit by, no contamination or whatever on there. So yeah, that's another one. We already went through this here. If you want to see where this little thing up here, that's where, so this is where what we call karyogamy, that kary is the nucleus. So the two nuclei fuse. So there's the N plus N, and then they come together. That's where you get the 2N, right? And then they undergo meiosis, that's meiosis. And then we get the spore, those 4 haploid or N spores. And notice there's a little clamp connection there. And notice over here, clamp connection. So after this thing becomes dikaryotic, so notice that it has a monokaryon here and another monokaryon. So they're illustrating there's 2 monokaryons here. They come together, they mate, and then and then after a while you get the dikaryon, right? So there's just one more diagram of that whole process. I think we already went through this. Again, I could go through this homo hetero thing if you want, but probably don't need to. I think that's a bunch of stuff that I said already. So yeah, we could talk about the sexes, I guess, a little bit. So we were already talking about this. Again, I'll send these, I'll send a link to these slides to Andrew here. So I know this is a lot of information and you guys are probably saturated already. So, and like I said before, you guys feel free to, please, I would encourage you to actually send me questions, because the more I can refine these ideas and the more I can flesh out these ideas that maybe don't make sense to other people, the better the eventual book that I'm going to try to write will be. So yeah, this is all a bunch of the same stuff we've been talking about here. Let me look at the questions real quick. Once I start working with spores, Lord save me from being a total idiot. And idiot I'm okay with, but not total. I know this is a microscopy talk, but can you briefly talk about checking? Yeah, actually, Strand Farmer, that's exactly what I was going to do next. This is kind of a microscopy talk, and this is what we are talking about here. Let me see. I think I have an actual. So let me hear real quick. There are other ways. Some of these slides are like duplicated. There are other ways you can do nuclear staining. To be honest, this nuclear staining with things like acetocarmine, they're really messy. If you've ever done this, like maybe back in high school or whatever, these stains, I hate working with these things. There's things like acetocarmine, and there's a few other ones like DAPI, which is a fluorescent dye that'll stain nuclei. There's other things like Giemsa staining and things like that. I hate doing these things. And in order to stain a fungus, you might have to do different techniques, because the fungal cell wall is going to be a pain in the butt to get those stains in. And there's all these kind of things that I'm not going to do, and probably not many other people are. So the easiest way is to use the clamp connection, or the lack of clamp connections. Let me see if there is I got a slide here. Oh gosh, where did it go? It's an actual slide that's got here. So when there are no clamp connections, you are going to hopefully have what's considered a monokaryon. So this is where I think I said about 3 hours ago, this is where the problem comes in, because if you don't see this, how do you know it's not there? There's something very strange about basidiomycete fungi, is that oftentimes you will have mycelium and you will see septa like you see here, and there will be no clamps, even in what you know is a dikaryon. And you know there are some clamp connections there. I'm sure anybody who's looked at my under the microscope at these fungi, you're like, this is a dikaryon and I see clamps, but they're not everywhere. Like, why? You know, in this kind of thing, you see a clamp there, you see a clamp there, and that, oh, that's great, but that's not normally the way it is. Oftentimes you will see septa that do not have clamps. Like, I mean, quite literally here, like in this, you see, you know, there's a septa there, and it's usually got this little, it's kind of like a little humpy thing. You see it, and you're like, all right, there we go, dikaryon. But then you'll see all these other septa, and they don't have any clamps, and you're like, you want to pull your hair out. And so this is usually at 400x. There's different ways to do it. So some people, so some people will essentially, they look at it through the plate and they'll look down on the mycelium. My microscope doesn't really have the ability to do that. My microscope, I have to be closer to the subject. But some microscopes, better microscopes, you can actually, and some people will flip the plate over and look through the back. This is why a lot of people like using gel and gum, because you can look through the back of the plate, and some people will actually pour their plate so that the media is super thin. And so you can see the mycelium through the back of the plate. Some people will actually take the lid off and crank the microscope, the objective down to the mycelium. There's different ways to do it. Some people cut out little squares. Some people, I like to shave off a little piece from the, like I'll make a cut where I do the subculture and then I'll shave off a little piece and try to get almost like you were like taking a pat of butter off a bigger, you know, a bigger chunk of butter. And I get a little pat of that and then I'll do a squash mount. Some people don't like doing that because it takes a little bit extra effort, but I think it's fairly straightforward to just, you know, you shave off a little piece, you put it on a microscope slide, and then you squash it down with the cover slip. And then I look at it at 400x. That's my preferred method. You don't like destroy the clamps. If the clamps are there, they are there. You're not gonna, you might see them where they've like separated from the septa, but you will see, you know, it's like you take the nut off a bolt, you still got the nut and the bolt, right? You know, it's not like you've destroyed the nut or the bolt. You can see both of them. And so, yeah, this is extremely frustrating because you can literally spend 10 minutes sometime. I know I have cultures. It's the same with fruit bodies, like actual fruits. Sometimes when you read the description of mushrooms, they'll say something like, well, there's clamp connections in the base of the stipe or the stem, but not anywhere else. And you're like, what the hell does that mean? Like, you mean literally there's clamp connections in part of the mushroom, but not other parts? Like, and that is quite common. Very, very common, where, you know, there won't be clamp connections in the cap hyphae, but there will be in the stem. And you're like, that doesn't make any sense. It's the same thing with cultures. You can literally look at a culture that you know damn well is a dikaryon, and you're looking and you're looking and you're looking and you don't see clamps. And it's so frustrating because you can literally like see a fruit body, like a little, you know, pin on the plate, and you're looking for clamp connections and you don't see any. So I'm going through this problem now. Like, for instance, say somewhere like this, I've got this, I don't know if you guys will be able to see this, but this is like a albino chode wave. And you see it looks really, really kind of messy and ugly and tomentose. But I know 100% this is a this is a dikaryon. This I know is a dikaryon. I've fruited it. I know this is a dikaryon. And if I look at that, I may or may not see clamp connections. And it drives you absolutely bat crazy. And it's one of those things we just got to deal with. So that's if you're looking for dikaryons with clamps. So imagine if you're looking for a monokaryon and you're looking for the absence of clamps. This is where a lot of people make mistakes, is that they think they're looking at a monokaryon and it's either a contaminant, which won't have clamps, or it's a dikaryon, but they just have not found a clamp. You compound this with the fact that not a lot of people have microscopes, and not a lot of people know how to use them correctly. And then so what you end up is you got a lot of guys who end up thinking they're doing mons or diamonds, and they're not. They're doing a dye, or they're just re-isolating. They're essentially growing another dikaryon that they isolated from spores, which is fine. You know, it's it might look different. And so this is what tricks them into thinking this, because they've re-isolated another dikaryotic strain from the same mushroom. And it's basically the same mushroom, but maybe it looks a little different. And they think they've bred something together. So they go and they post it. And, oh, look, it's my Bunel crossed with a Stero or whatever. And it's the same thing. It's either a Bunel or an Astero, and they just don't realize that they were trying to breed two dikaryons. And they just re-isolated and then grew one of them. But yeah, so I mean, the genetics of this, you can get really, if I had another PhD to do, yes, I would. I know. Well, there's about 7 things I would probably study, but that would be one possible candidate. But I don't think that's going to happen. But yeah, let's see. Did I answer the question? Let's see. Man, my contacts are bugging me. I know somebody. So I've heard that. Not all dying. Oh yeah, so that's another thing. Yes, there are plenty of basidiomycetes that do not have clamp connections. Like I was saying, there's certain fruit body is that like mushrooms that literally, if you read the description from Singer or Alexander Smith, they will say stuff like the cap trauma doesn't have clamps, but the stipe does, or the base of the stipe, or the pileopellis of the cap has clamp connections, but the rest of the cap doesn't. And you're thinking it's like one of those techniques they used to separate species back in the day before we had DNA. And it would be something so obscure and so difficult to either confirm or, refute, that it was like Singer and Alexander Smith, like going back and forth, like, well, that species of Agroscopy is different because it's got clamps in the base of the hyphae at the base of the stem, but yours doesn't. And like literally they would use that as like a reason to like separate species because they just wanted to publish a paper just like now. So now it's like, well, that's got a 2.6 different base pair, different blah, blah. Anyway, that's what people do. Those are called the splitters. They want to publish papers. And that's how they did it back in the day. Let's see. Answered it. Oh yeah, and certain things like Andrew. There's a very famous one that is Armillaria honey mushrooms. Armillaria do not have clamp connections either, and so this made it really, really difficult because they were trying to separate them into biological species, and they were doing it because they're quite intensive, like plant pathogens in the eastern United States and in Canada, and out west also. And so they were trying to separate all these, what they call biological species of Armillaria. And they were pretty certain it was, they were based on their ecological niche and their hosts. And they were trying to do it based on mating studies. And the problem with that was like, not all of them they didn't form clamp connections. So when you do these, when you're testing the biological species concept and you want to see if two things are the same species, you take two monokaryons and you put them together. And if they form clamp connections, you can assume they're biologically compatible. Well, it turns out for some of those Armillaria species that didn't work very well, and so that was a problem. That's actually what I did for my PhD. So yeah, let's see. I need to wake up early for my kid tomorrow. I'll watch again later. Thanks, Ed. Okay, good night, Vincent, wherever you are. Any microscope recommend to a beginner? Yeah, an what's it called? An Amscope B120. Amscope. They might have like changed the name or something now, but that's the basic idea. An Amscope B120. I think it's about $250 now. To be honest, I would stay away from used microscopes. I have heard so many horror stories, and I would just like stay away from used microscopes. They're gonna have problems with the alignment of the optics. The pieces are probably gonna be mismatched. They've probably changed out the objectives. One of the very expensive parts of a microscope is like a camera lens. You know, it's not necessarily the body, as long as that works. It's the lenses, right? Maybe now with digital bodies, but I mean, back in the day, and still, it's the lenses, right? You can buy like a $10,000 like camera lens, or you can buy a $50 one, and they basically gonna both fit on the same camera body, right? Microscopes are kind of the same way, in that like you can end up getting lenses that may not be what was advertised, you know, or may not be original. Some of the school I was teaching at, some of the microscopes had that exact problem. The objectives that had different focal lengths, so every time you were changing the magnification, you would totally have to refocus everything, you know, like a half-inch difference. So normally the objectives should be what they call confocal. They should have a relatively, like when you spin the turret and you go from like a 40x to 100x, it should be roughly focused. But yeah, if you change out the objectives, which are the expensive parts, that will not be the case. And that's the first thing somebody's going to do if they're selling a microscope on like eBay or whatever they use now. They're going to have changed out the objectives. And so you won't be getting the original objective. So I would just buy a brand new microscope, and don't buy a cheap one either, like a monocular one. Some people, they're like, well, they look cool. Monocular microscopes, you'll end up putting your eye out, you know, that little, what was his name? Not Timmy. What? You'll shoot your eye out. Like you'll end up poking your eye out with the microscope. Get a binocular microscope like that Amscope 120. B120 or whatever. I wouldn't go any cheaper than that. As far as upper limits, you can buy a $50,000 microscope if you want, but you probably don't need that for looking for monokaryons. Yeah, man, I haven't talked this long in quite a while. Normally I just stay home and like I don't talk to anybody. I just talk to my mushrooms. Yeah, that's another good thing. Grow fresh. Yeah. We're getting down to the last 30 minutes here. I think, Andrew, it's 5 hours, right? Or 6 hours. We're getting down to the last 30 minutes. So if you guys have any questions, please put them in. Oh yeah, I wanted to show you the grab and drag thing just in case it's not, there's one of those things about so I wanted to use this to illustrate the fact that, yeah, like Andrew was saying, there's no way you can just look at a culture and know that it's a monokaryon or a dikaryon. I hate to say it. Those guys, there's a reason why they say that. And that's because they want to sell cultures and they want to seem like there's a couple guys in the communities that have exceptionally big mouths. And so they tend to get a lot of attention because they just, you know, but like they say, usually the loudest person in the room is the one you don't need to listen to because they don't know what the hell they're talking about. But just because they got a big mouth, it doesn't mean they know what they're talking about. So yeah, the grab and drag thing here. Let's see. So you can do what would be not. Let me show you guys here. So there's a couple techniques. I'll just overwrite on this slide here. So my original idea with the grab and drag has a few components too. You get a single. So you see here out on that scalpel. I don't know if you can see it very well. Just using. He's just using it to point there. This was actually, I think it was somebody else's slide. I can't remember where I got this from, but. Anyway, the idea is you can take the end of that scalpel and you take your, make sure you sterilize it and cool it down 100%. And you can even dip it in the agar if you want. So then you can take the back of your scalpel and you can drag it through. But don't get more spores. So essentially you pick up a little bit of spores on the scalpel and with the same load of spores, you go shh. And then the same load again, you shh, shh. And the idea here is that you're serial streaking. Another way to call this would be serial streaking. but you're not getting new spores. So the idea, and as you're going through here, maybe twist the scalpel a little bit. So you're trying to drag off spores. And the idea is as you drag it along, there might be a little spore left there, and then another one left there, and then another one left there. So as you can see on this plate here, what happened, right? There's a colony, there's a colony, there's a colony. And then you can isolate those. And the hope is that those would be single spores and that colony is a monokaryon. That's the idea. So call it whatever you want, grab and drag. Somebody actually dubbed it the grab and drag because the original idea I had was you take your swab and you grab. So one of these things are way back there. You take a swab and you grab, you get one of these, like these things, and you grab a little piece, a little tiny piece. You grab it with a tweezers, and then you take that tweezers and without releasing that little tiny, hopefully maybe 2 or 3 threads of that cotton swab, you take it and you do the same thing. You drag it through the media, right? So that's where the grab and drag come in, because with the same little piece of the same, God, I lost my thing here. With the same little piece of cotton threads, you're dragging it through the media. And as you do that, hopefully some of those spores are getting ripped off and they're depositing themselves. My goodness, I don't know where that went, you guys. They're getting drugged through there, and they are essentially depositing themselves here and here and here and here. And then so when they germinate, they're not going to dikaryotize. And so you can isolate them onto a new plate. Here's the thing. If you've got fresh spores, that process, fresh spores will germinate in 3 days, 4 days. You need to get those on a new plate, because you see right here what's happening. That is a mon, right? And they are dikaryotizing there. So this person is accidentally doing a mon, but it's with the same spores from the same mushroom, right? So like this part, you don't want that. Like you want things like this. And so, this is where you need to be really careful and accurate and not have too much coffee and whatever, and you want to pull off a little tiny piece. I mean, you're talking like literally. So if this is a rice grain, right, you want that much. You want a tiny, tiny piece. I mean, we're talking like a 0.5 millimeter squared. Like this is a tiny, tiny, tiny little piece. And so you want to get your nice sharp number 11 scalpel blades, and you want to get in there. And the idea I use is like kind of like you're almost chipping something, like if you were trying to like chip paint or something off a wall, but like pretend like the agar is like a paint, and you're trying to like get in there and like chip a little part of it off. And you get that onto a new plate, and then after a few days it'll start growing, and then you've got your little colonies, and then you can check them later to see if they have clamps or not. So something like this, right? There's 3 of my MVP monos, and I might check those. Since we've talked about them so much, I might go check those later. Again, I would love to be able to show you guys that stuff on a microscope, but I am just not set up to do that. And so, yeah, that's the grab and drag essentially. And it's pretty cool because it takes just like one plate. I mean, you could do it with 2 or 3 plates, but that plate right there potentially has like 20 different monos on it. So it again comes to like a numbers game. It's like, how many do you want to pull off and put on new plates? I usually put 3 to a plate, and then I check them after a few days after they've grown out. You want to wait till they grow out a little bit, because if there happens to be 2 spores. So here's the thing. This is why you want such a small piece, because if there's 1 spore, if this is the little area and you're pulling out there might be a spore here that's germinating. But there might be one there that hasn't germinated yet. So you pull off this big old piece, and then now you got 2 spores, and then they dikaryotize. And so you've wasted your effort. So the idea is to literally get like a millimeter piece. I mean, like for non-metric, like a 32nd of an inch piece, and get it onto a new plate. Make sure your scalpel is well cooled off. Otherwise you'll kill the spore or the hyphae. That's all you need. It's incredible. Like one little piece of that hyphae on a new plate. So that's the grab and drag, and that's pretty much all. That's it. That's literally all it is. There's nothing fancy. It's a modification on streaking. You could do the same thing with streaking. The problem with streaking is you're not gonna generally isolate single spores. And so that's why people used to do the serial dilution. That serial dilution with the syringes that somebody mentioned earlier, that's kind of a really cool idea too. Yeah, where you can just basically use a tiny little bit of the spore solution that you might buy from a commercial vendor, and then dilute that in a syringe with sterile water, and then squirt a couple drops on plates, and then get a new fresh plate, and then dilute, like squirt out 9 of the 10 millimeters, and then suck up fresh sterile water to dilute that remaining 1 milliliter. Then squirt a couple drops on a new plate, and then do the same thing again. Squirt out the 9, suck up a fresh 9. Yeah, and do serial dilution that way. That is a very probably efficient way to do it. But again, in that case, I would worry about the spores being sort of clumped together. With spore syringes, the spores tend to be quite clumpy. I mean, you can see in the syringe where they're sort of clumped, like big black specks. If you can see a clump of spores with your naked eye, that's like 1,000 spores. They're so tiny. So yeah, I think that's the grab and drag. See, sorry, out. Under 400x mag, how do you look before you're at least? How long? I personally, so this one under 400x, how long do you look? I personally will spend at least 10 minutes if I find what I think is a mono, because you got to remember how much work you're going to do with this mono. I swear these monos, like, so I'll go look at these putative, they call them putative. That's the word. It means like potential. Putative is a fancy word. So if I had to guess, again, looking at growth characteristics, these are probably maybe monos, but I'm not going to assume that based on their growth characteristics. So I'll go and I'll chip off a little piece from each of these colonies. And especially because I'm using this weird media, this gelin media now, I don't know what they're supposed to look like. I will check these probably at least. So I'll pull a little piece off there, check it. This time, put it on its own separate plate if it's a mono, or if I think it's a mono, and then I'll check it again probably in a few days after it grows out successfully, hopefully. And then I will check it again before I use it. So I'll check at least probably for 5 to 10 minutes each time, because remember how much, and I know most of the people that are doing these mono mating things, they're not spending more than probably 30 seconds checking their monos. And I see what they do too. I see them looking through the top of the plate, and they're using like 100x. You can't check for monos at 100x unless you've got some, I don't know, exceptionally good eyesight that I don't have. I like doing smash mount. So while back here, this is what's called a smash mount or a squash mount. Sorry, I couldn't get a higher resolution photo. Here is the microscope slide. So your microscope slide's going to be, if you were looking at it from the top, your microscope slide's there. You take your tiny little piece there, and then you take, so this is from the side view, right? So there's your slide, and there's your material right there. And then so you take your slide, and you go down there and take your thumb and kind of push down real gently and smoosh it down. Like you're making like a peanut butter and jelly sandwich, and you're mushing it down, and that jelly starts squirting out the sides like that. And that works pretty well at 400x. You can also look at 100x. So that's going to be 10x of eyepieces and a 10x objective, or a 10x eyepiece and a 40x objective. You can also look at 1000x, but 1000x on my scope, at least you have to use oil. And I find oil really, really annoying, and it gets sticky and gets on everything. So I just use 400x. So it's one of those things. It's like personal choice. I mean, if you're happy with 2 minutes, go for it. I'm not. I'm like OCD about making sure my monos are monos. Especially before, because I was going to sell some of them. And so I mean, that's like the worst possible thing you could do would be to like sell a mono to somebody for like $100 and then find out it was a dikaryon. So what I did, I went above and beyond. I actually mated this mono that I was going to sell with about 5 other things to make sure it was compatible with other things before I ever even thought about selling it. And then I sold 3 of them. So probably about 6 months of work, I made like $360 for like 6 months of work, and God knows how many plates. And you know, the thing with mushroom farming, if you factor in your time, you know, you're not gonna make any money. Anyway, tips for getting dry spore prints. I'm not sure. What do you mean dry spore prints? What I do is I use one of these boxes. I use let me grab it. I use one of these boxes. So I just use like a Tupperware box, and I will take aluminum foil, and I cut it about the size of the bottom. So I put the aluminum foil down on the bottom of the box there. And then I usually flame it. Actually, I'll take the aluminum foil and I have a tweezers and I flame it with my little butane torch, you know, my little like dab torch or whatever you call them. Even though I don't do dabs, and then I put the foil down there and I just put my cap right there on top of it, and I cover it with this, and then I let it sit for 5 or 6 hours and check. And if it's good, I'll take another one. You can make multiple prints from a single cap usually. The first one, sometimes people say is like a burner. They don't use that one, but I don't know. I don't see it makes that much of a difference. If your grow is clean, you can usually get 3 or 4 good prints off a cap. And yeah, I haven't really found any problem with using the first one or the third one or whatever. There's going to be like millions of spores there. So as long as you're clean, there's other tricks, but I don't know about wet. The problem, if you're getting a wet spore print, you're leaving your cap probably too long. You should be able to get a good spore print in about 3 or 4 hours. If you've got to leave it to the point where it's like giving off so much moisture where it's condensing and you're getting like pools of water, then that's too long. So yeah, I'm not sure how you would get a wet spore print other than that. You're probably leaving it sit there too long. If you're really worried, take 2 chopsticks, get a cheap pair of, not a cheap pair, like from the Chinese takeout or whatever, and take 2 chopsticks. And you can, you flame your foil and then maybe just spray the chopsticks with alcohol and put them on there, and then rest your cap on the chopsticks. And so that'll keep it off the foil. Like if you were getting a spore print of like something that was maybe like a Ganoderma that had been outside in the woods for like 6 months, you probably don't want it right on the foil. Or if it was something like, say, a Hericium, you'd have to maybe create some kind of, I don't know, what do you call it, like a scaffolding thing. Or what I used to see people do, you can actually take like a window screen, that old school, like, the metal window screen, and you can make like a little, almost like a bridge. Like, that thing when people like you take like a piece of paper and you like fold it like that on the edges, and then so it would be on a metal screen, and then put your mushroom up there. So it's kind of like suspended over your foil, like maybe a 1/2 inch or so. The other thing, here's a really good trick for if you're going to make spore syringes, what you can do is get a clear drinking glass. So like, let's see. So like this, but pretend there's nothing in it. So this is a clear glass that you've maybe sprayed with alcohol and allowed to dry out well. Take your mushroom cap and put it on top of the glass here, and then allow the spores to drop down into the glass. And then what you can do later is you just shoot in sterile water. This is how those guys used to sell those spore prints, or the spore syringes, multi-spore syringes. Some people still do. and they get them so clean. You're like, wow, are they getting these really super clean like spore syringes? Well, they do that literally, or they take, again, like a metal grating that they flame sterilize, and you put your cap on top of that and just let your spores fall down into the sterile jar. And then you can just cap it up after, and you put some sterile water in there, you cap it up and just shake the hell out of it. And then you pull your syringes, you know, so you can get, I don't know, 50 spore syringes out of a jar like that. And so that's why, I mean, that's why they used to be able to sell, you know, you buy 3 spore syringes for $20, but the dudes are still, I mean, you got like a mono tub full of GT, you can make a hell of a lot of spore prints, you know, so you just get a big mason jar, you know, what is that, about probably 700-800 milliliters? That's 60 spore syringes, right? And you can sell for $5 a piece. So yeah, that's how some of those way old school, you know, the back of magazines, you know, they used to sell them for $10 or 3 for 20 or whatever. So that's another way to get into the you know, mushroom world. Let's see. So that's the dry spore prints. There's probably some other things that I'm not thinking about. Can't remember. FY for those interested, syringes block UV light. Oh yeah, that's a good point, Andrew. Yeah, you have to like open the plate when you're doing the UV mutagenesis thing. Yeah. What was it? Yeah, I think there's some famous story about that. So my brain is I'm running out of ATP here. My mitochondria aren't producing enough ATP. Maybe needed some methylene blue or something. I've been using Lose spores and micropit plates. Yeah, that's a good idea. Grow fresh. Yeah, it's funny. I never really thought about that, but that would be a pretty good idea, a pretty good way. But like I said, I would worry about the spores still being like clumped together. I've just seen so many spore syringes where the spores are like literally like clumped. And I always had trouble getting those clumps to separate, even if you're using a vortex, or I know some people, you know, hook them to like Sawzalls or whatever. I just, what I would do is I would put tween 20 or tween 80. I don't know if you guys know that one. If you're having trouble getting single spores, you can use what's called polysorbate. Polysorbate 20. I think 20 is just a reference to it, or 80. I don't remember. It doesn't matter. One of those. Or sometimes they call it tween. I think on the internet, it's generically called polysorbate 20. Sounds like some kind of sugar or something, but it's, yeah. Polysorbate 20 or polysorbate 80 is it's a detergent. It's basically like soap. Or you can just use dish soap. So if you're actually making your spore syringes or dilutions or whatever yourself, just literally take like, I mean, like not much, like a toothpick, dab it in some Dawn dish soap and mix it with like your, you know, your cup of water, 2 cups of water. Like don't put like 3 drops of dish soap. You'll end up like, you know, washing the dishes, like literally like the end. I mean, just a minuscule amount of that dish soap, plus the dish soap, probably not great for the spores. Some people say like if you add a little bit of dish soap to your spore dilutions too, it'll help them germinate. That the surfactant, you know, it helps wet the spores, and that maybe it sort of helps the membrane absorb a little water or something. I don't know. I haven't messed around with that very much, but I've heard that before. See, I've seen some tween, but I haven't used it. I just got agitating the shit out of this one before. Yeah, I mean, any way that works. That's the thing. The other thing about like all this breeding stuff, people tend to get really like particular about, I use this way, I do that, and then like they think it's like some kind of competition. It doesn't matter. However you do it, if you create something new, man, it doesn't matter. If you did a grab and drag, a serial dilution, I don't know, you just mixed 2 multi-spores together and shot them into a PF Tech cake or whatever, it doesn't matter. But people get really super sensitive about all this stuff. I see breeding as a leverage multiplier for small fight. That's the big thing. Yeah, if you can create something that's unique, that could be a game changer. I think it really doesn't. The only problem is these days you got to be into marketing. You got to really, really be into marketing, and that unfortunately means like being into social media. I don't know how it works for you guys. Maybe in a smaller place. I've been thinking about this actually. I'm without divulging. Yeah, I don't know. I need to think about this a lot. Branding. I'm not really super good at branding. That's actually something I admire quite a bit about Andrew. Is he seems to be much more keen on the branding and the social media stuff. I don't. Well, I mean, I am a little bit restricted because of my species of choice, but it's one of those things I definitely need to get my game up on. I guess I'm between 20 sterile and non-sterile, assuming if I can use it down. Yeah, you can actually I think you can pressure cook tween 22. I put it in the pressure cooker one time and it didn't seem to have any problem. Make tween high sterile. Yeah, I make tween. Well, I make tween. Sterile water dilution over tweening. Yeah, that's the thing. I'm the same way, Andrew. I'm sort of like one of those people, like I feel bad, like blowing my own horn kind of thing. But there's other people that seem to not give they love blowing their own horn. But I'm one of those people that I'm very, I don't know, with maybe humble might be pushing it a bit, but I don't like to brag or blow my own horn. So here's maybe an interesting slide where you can see where I've subcultured these. These are the pieces that I put onto new plates. So as you see, these were Paniolus asteros, Paniolus species, for if you didn't know. So I checked like 4 of them and I got to 4, and then I didn't even bother with these other ones. Another neat thing to check your original, like I said in the other side, keep your T0 plates. What you can see here is you'll accidentally be doing mon crosses. So the good thing about keeping your original plates, when you isolate these things, you can see they'll eventually grow together and it'll be like your own. It's like a an accidental mon. And they will dikaryotize, and sometimes you'll see little fruit at the interfaces, and that's kind of cool. But yeah, that's another thing. This was a slide here. I don't know. Some of you guys will probably have to might want to look at in that book. Like I said, this is from that book. That book is brilliant. This dude, Bart, I'll just call him Bart because I have no idea how the hell to say his last name. Nieuwenhuis. Let's just call him Bart. Bart is obviously a very smart dude. And so yeah, this thing. So if you notice here, like the most basic example, mon. So this is where we had that kind of reciprocal thing where you can see here, the gray, the colored stuff that represents the cytoplasm, and the white here. So those are 2 different cytoplasms. And so here you have where it's basically like, one of the white nuclei comes over here and one of the black nuclei come over here, and you get this situation where you got 2 dicaryons, but they keep their own cytoplasm. That probably doesn't happen. What probably happens is maybe more something like, I don't know, like the diamond mating thing here. I don't know, to be honest. I don't know. You can go read his book. He goes into a bunch of different possible explanations, and this figure here is just like kind of the tip of where he starts discussing these things, and it's deep, man. That book. It's deep. And feed it through Notebook LM. I did, and it gave me like a 20-minute audio podcast, but it was really sort of generic and didn't really like this diagram. I was looking at this one day, and I actually printed it out and have it up on my wall, and I look at it, I'm like, oh my gosh. What's neat sometimes is with the diamond thing, again, you'll have to do pheno hunting. So these were some diamonds that I did. Oh, here's another neat thing before I forget, you guys. If you have kind of like the idea of growing a monokaryon spawn and shooting in multi-spore syringes, you can just throw in a dikaryon. So what I used to do, here's my bag, and there's my spawn. I throw in my dikaryon, and then I throw in my mono, and I just let it do the mono diamond thing in the bag. Just let it do it in the bag. Don't waste an agar plate. Just throw your dikaryon. And again, if worst case scenario, you're just going to grow a dikaryon, and better case scenario, you're going to get the original dikaryon, So you can see here, like this is probably the original dikaryon, and maybe that's one of them that exchanged the nuclei, and who knows, maybe that's the other one that exchanged the nuclei. But yeah, you end up phenohunting and something like this, right? I don't know. It's fun. It's just fun stuff. Somebody mentioned cloning earlier. I think you guys would probably already know about this. There used to be this weird rumor that would float around that said, like, you can have these chimeric fruit where you can have multiple dikaryons, and that's also bullshit. If you get a fruit body, there's not like mixed dikaryons. People used to always say, like, well, you got to clone near the base so you don't get multiple dikaryons. And yeah, those were guys that probably didn't know what they were talking about. In a multi-spore, like you can guarantee that that dikaryotic flesh and this dikaryotic flesh is the same exact genotype. I don't, again, know where that thing came from. I don't know. But people, there's a lot of weird ideas floating around in the mycology world. So... And I think we covered that Punnett square good enough. Yeah, DDK, that's a whole other thing. That would be I don't know. Do you guys have any questions? I think we're at the 4 hour, 5 hour. Does anybody have any other questions? I think don't want to be redundant there. Here, if you want to know how that how these things work. So supposedly this, I don't know, this is how we say the one of the red nuclei migrates back into the other previously existing septa. This is why that idea about dikaryons propagating once they form, like none of this makes sense. If that doesn't make sense when you see something like this, like if this thing out here at the tip forms a dikaryon, like how are these nuclei gonna get back, you know, to the previous existing mycelial cells? It doesn't make sense. Although supposedly nuclei can migrate through the septa, some of the mushrooms have, like, what do you call, permeable septa, but I think that's just another stupid myth that got propagated. That's pretty much it. If you want to. There you go. Cordyceps. Yeah, we talked about that. Yep. So a bunch of other crap. There you go. Yeah. I think that's it, you guys. That's about all I got. If anybody got any more questions, let's see. Let's see. 50-50 grain, where the hardwood fuel pellets work during a little pseudo PF. Oh yeah, I was, yeah, exactly. That's what I was thinking. I was thinking it wouldn't even necessarily have to be like little, but I guess yeah, I guess the problem is that do spores germinate on hardwood fuel pellets? I think that would be the problem. Like cubensis spores will germinate quite readily on brown rice flour that's, you know, adhered to vermiculite. But I don't know, will gourmet spores grow in hardwood fuel pellets? I mean, maybe if they have the soybean hulls, I guess that's a 50-50, right? So that's like a master's mix. Would the spores germinate on that? Let's see, what should I be transferring when I do Daimon? Yeah, grow fresh. I think like if you do a Daimon on the plate, it depends. I would just put the whole thing. So here's the thing. If I were doing a Daimon, I would do, here's your dikaryon, like right there, and your mono right there, and then they grow together. I would just cut out the whole thing. You cut out both of them, throw it in a bag. So when I was doing that, So you could isolate from right here, but I figured, what's the point? You're just wasting a plate. So I just started cutting out the whole dang thing and throwing it in a bag. It's like, I don't want to waste an agar plate. I don't need to wait for it to grow again. I can just chuck it in a bag. And so then I got to the point where I wasn't even putting them on plates. I was just taking the dicarion and the mono and throwing them right in the same bag. And then I would kind of mash them together, like in the bag, and then just let them grow. It worked really well. So I wouldn't even waste a plate, because you got to remember, if you get a pheno that you like, a phenotype, you're going to clone it anyway, right? So there's no reason to like put that little interface onto a new plate, because if it grows successfully, you're just going to clone it. So like, I was like, let me just save a plate and I'll just throw it in the bag. I'm working on a book and an AM calling the School of Unnatural Study. Just talking about it. Yeah, sounds good. Over the years, I've had about 3 books I probably should have written, but maybe lost the window for that. Organism putty in your hand. Oh yeah, 50-50 makes you make what we call breeding. Oh, so the spores will germinate on what do you sometimes do? So yeah, Strand Farmer, this was what I actually had a couple slides in there. Maybe like Grow Fresh says, growing conditions. So yeah, this here, one of these slides here, that was the idea with those slides was that, there you go. It's what, I mean, fancy, you can say, like, there's kind of the explanation. But yeah, that's kind of here's the basic idea. The basic idea. A lot of different reasons. I don't know. You could read these. Again, I'll give you guys these slides. Essentially, it's growing conditions, but like Andrew was asking about, also, there's a lot of epigenetic factors. There's a lot of genetic factors that can be turned on and off that are, I mean, more broadly in a nutshell, you can say environmental conditions. It's kind of like, imagine humans, if you had like 2 identical twins and you put them in different countries and fed them different food, and they were, they would speak different languages and all of these different things because of the environment. But then there's all kinds of other possible genetic factors that we just don't even possibly understand yet, especially with mushrooms. So maybe something like a temperature change that you just think, well, if it's colder, it'll grow slower. But it may be doing other things like turning off certain genes, turning on other ones. And so something just like some simple, like me moving from Bangkok up north here, like all of my strains, that's why I'm going back to spores. So here's one of the neat things is, if you do go back to spores, if you have a different environment and you're wondering, and you've got a strain that's not really cooperating, or it's not maybe growing as well as you'd want it to, go back to spores and re-isolate from spores, and maybe do one of those multi-spore grows where you're taking a bunch of spores, or like a breeder's block or whatever. So go back to spores and essentially look for something that grows better in the conditions you're growing in. That's what people have been doing for years. That's what farmers unknowingly have been doing for years, right? You get some corn seeds, you go to a new field and you plant like 100 seeds. It's what they usually call mass selection. And they essentially, what are the seeds that you save for next year to plant again? They're the ones that grow well the previous year, right? You go through the field, you look for the big corn cobs, the big seeds, you throw those in a separate pile and you keep those for next year. Like, that's essentially what farmers have been doing for the last, 5 or 6 millennia. And they just keep doing that over and over and over again. And you eventually get better crops suited for that environment. Now, if you take those corn seeds and you switch them to, take them from Kansas to Montana or New Jersey, it's going to be an entirely different situation. And you're going to have to go through that process again. And that's what humans have been doing for millennia, right? We're just getting around to doing it with mushrooms now. And along that note too, there's some people that will say like, well, we're isolating and they're getting all, we're isolating all these things and we're bottlenecking our genetics and, there's too many strains and blah, blah. Just ignore those people. Most of those people that make those comments, they pretend like there's some population geneticists or whatever. I mean, what, cheetahs were down to like 70, and like they are not cheetah. The buffalo, yeah, just ignore those people. Most of the time, those guys, they're just looking for arguments. There's no way we're bottlenecking genetics by isolating these strains. And yeah, shut up. Is there any problem with cloning over and over again? The only problem would be probably, again, if you get some kind of genetic degeneration from, like, maybe the mitochondrial. So there's one of those slides back there. I want to try to find it again. The mitochondrial ratios. So essentially, I think, like Andrew's, says enzyme blindness, and essentially it gets lazy. Like if you're going to clone again and again and again, you're going to get the strain's probably just going to degenerate and get lazy. But if you change your media, change your substrate a little bit, I mean, that's kind of the traditional practice, just like mix up your media every once in a while, either your agar media or your growing media, your substrate. You don't have to go back to spores necessarily, but it's good once in a while, just for the hell of it, to go back to spores and see if it does anything. I don't know, but again, like cloning over and over again, I don't know why you mean cloning. Like if you're going to go through the effort to clone a fruit again, you might as well just get some spores while you're at it. But yeah, I could see why it might be detrimental after a while, but I don't think it's probably not as like bad as people pretend it is. You got to remember, a lot of these people who say this kind of stuff are selling cultures and selling their genetics, and they want you to buy new genetics, right? So if you have a culture from them and they're like, well, you better buy, you better not clone too much. Well, because they don't want you to be self-sufficient, right? Because they want you to buy their stuff again. So is there any problem? No. I have cloned mushrooms grown in the exact same kid, different. Yeah, so like we've said a couple times, it's the environmental conditions, Tran Farmer. It's Yep. As soon grow fresh. As soon as we sign off here, I will send Andrew a link to this on my Google Drive, and he can download it and send it, or send the link to you guys or whatever. Yep. Sorry, it's a little bit out of order. I've been messing with this presentation for like 3 or 4 days, and I used it for other presentations too. So the slides may be not in the most logical order, but I don't know. It's all there. Like my spores with German and hardwood fuel pellets. Oh, okay, but they need to be wet. So I use a 60. Oh, that's cool. Yeah, I've never. To be honest, the wood I get here is really bad quality. I don't know I think it's the rubber trees that they grind up, and they use it for growing mushrooms. But every time I use it, maybe I'm just getting like really bad quality. Every time I use it, I try putting in my substrate. Like we talked about trying to acclimate a cube to like sawdust or something, and it was like, every time you throw in sawdust in my substrate, it just goes horribly wrong. And I end up throwing a bunch of stuff away. So I don't think I'm going to do that anymore. You're the man, doctor. Help me with some crucial questions. Cool. Yeah. Again, you guys, if you got questions, feel free to send me an email. I prefer like Facebook or, I really only use Facebook and that line now, or WhatsApp. Email I can do too, but I don't really like replying to email that much anymore. Cool. Land races. Farmers have been making land races. Yep, exactly. Throw weak strains on dog food or some avocado peels, just whatever's around. That's like, is there ever a point when a mycelium mat has more than the traditional 2 parents, other than a 2+ half types? The mycelium mat has more than traditional 2 parents. I mean, I suppose out in nature, So yeah, when they did the thing with all those armillaria species, they would find, and I think I've heard Andrew talk, maybe somebody else talk about this, where you can look at one log and there will be like, say there's like one log and they had like, so there'll be like one log here and they tested like a mushroom over here and a mushroom over here and the one in the middle, and they were all different genotypes. And so they were thinking that there's little things here, like here's one dikaryon and here's another one. And then there's another one down here, and maybe they're sort of interacting with each other. And so this is really why Buller and a lot of people thought about this idea of the daimon. The daimon is probably a dikaryon, monokaryon is probably happening in nature a lot more often than we think. And this is probably a way, so some of these fungi that probably inhabit these logs for many, many years, if another spore comes floating along here and lands on here, it might be a way for these previously existing dikaryons to maybe generate some new, some new genetic variation. I don't know, I've heard various reasons why they think that this, like we kind of think of everything in as like a mon, like male and a female, and then nothing else, but no, there's probably a reason why this whole daimon thing occurs. So if you had like a mono that was here, and maybe just some random spore, and then, well, maybe it could pick up this and become a dikaryon, and they can make its own little fruit. There's various, you go talk to the population geneticist for that. But there's probably a reason why that daimon thing occurs in nature. It's just another, what do they call it, parasexuality kind of thing. Just another way for organisms to exchange genetic. And we didn't even really get to talking about viruses or anything. There are probably a whole bunch of viruses that mediate genetic transfer amongst these different colonies. And there might be things like transposable elements, which may or may not, I don't know, be exportable to different, I don't know. There's other vectors. Insects, maybe insects could be picking up and mediating some of these genetic transfers. There's just so many other ways that the fungi can do their thing. It's pretty cool. I mounted around in several cube strains that had been trained to hardwood phyllis, and they worked very well. He's in prison now, so yeah. What is he? What did he go to prison for? Did he go to prison for growing cubes, man? I hope not. Yeah, I'm kind of, to be honest, I'm kind of pushing the limits a little bit sometimes with what I've been doing the last few years. I do have people that have told me here that, like, pretty reliable sources, that within the next 3 years they will be legal here. Right now, I had a guy tell me the other day they've already made them. It's like Schedule 5, which is like basically like they're not interested. So I'm not sure. I'm not sure how worried I am about it, to be honest. To be honest, I'm not really worried about it. I got a little brief story. Yeah, I had some, like, if some people found my videos, also my old videos, and it created a little bit of an issue at work. I'll leave it at that. But yeah, I don't think I'll be ended up in prison. They would have probably sent me to prison already. In that case, can a daimon happen more than once to an organism? Oh yeah. I think the daimon thing, it can go over and over and over, like repeatedly. So yeah, that diagram, and if you get a chance, really look at this diagram in that book. It's in the, well, it's for third chapter, I guess, figure 3.1. He actually, and I know you can't read it from that slide, but go to that book and read about this diagram. It gets pretty dense pretty quick, man. That chapter 3, yeah, it's right there. That's where it's from. I don't know if you can. I think you can see that. Yeah, that's where that diagram is from. It gets really, really thick really quick. So So yeah, let's see. The case can for question you said WhatsApp is best. Yeah, WhatsApp, Facebook. Yeah, if you find me on Facebook, yeah. I don't know if my Facebook is. I could send. Andrew knows my Facebook. I don't care if you. The only reason why I put Facebook private was because I didn't want my students finding me. That's the only reason. What's your Facebook? I should just be Edward Grand on Facebook. No assault. Oh yeah, okay, good. That's why he's in prison for not for the cubes for assault. Yeah, that's the problem. A lot of these guys, I hate to say it, man. Even here, a lot of the guys who are interested in this kind of stuff, they have records that are not all pleasant. I mean, they're not like I've never been arrested, never been in trouble. I haven't got caught stealing anything or assault or anything. But God, some of these guys, even over here, that are interested in this type of stuff, they're like real criminals. And I don't associate with those kind of things. So it's a little bit weird. Some of the people that have approached me about maybe doing things a little bit, I don't know, larger, they're like real criminals. And I don't want anything to do with real criminals. So not going to deal with those people. So shall we call it a gate? Do you want to come back on, Andrew, to say goodbye to anybody, or you want to just shut it down? I think I probably said all I want to say here, and I really hope I can get rid of all the. I'm pretty sure. Actually, I copied it just in case right before we started, just in case that markup shit doesn't go on. Doesn't go. Yeah, what's fascinating with the diamond too, and back crossing also is another thing that I think is another. But I don't know if I still fully have a grasp on back crossing, to be honest. And I don't know if the phenotypes are that distinguishable that if you were back crossing something. So if you did a diamond, I don't know if my brain can process that kind of stuff right now. So yeah, I think that's it, you guys. Shall we call it, Andrew? Is anybody out there? Gotta pee again too. Thinking. Sydney Point. Yeah, this question about having more than two parents too, I'm kind of interested in. I read briefly something about, so this is where the idea of multinucleate. So when in that book, he starts talking a little bit, I think, about some of the yeasts and some of the other lower fungi, where they can have multinucleate mycelium. And that also is where things get like way more complicated, because I don't know, when you're dealing with multiple nuclei from multiple parents, I don't know how you even go about tracking that kind of genetics. But there are fungi that, like, especially slime molds and whatnot, that have multinucleate mycelium, and I don't know how the heck you go about tracking that. What? I think Andrew might be predisposed. Yeah, you guys, my mouth is not working anymore. So I think if I stop sharing, this will probably be the end of it. I don't know, you guys. I'm gonna hit the stop sharing button. It was really nice talking at you guys, I guess. maybe someday I can talk with you. After doing this, I am really, really tempted to go. I have a YouTube channel that has a few subscribers, but I don't know. Every time I watch Andrew, I'm kind of inspired. I'm like, maybe I should start doing the YouTube. The problem is I sort of have a real job now. And if I start talking about this stuff on a public forum like YouTube, they may not like that. so I may not be able to do that. I also, one of my friends was talking about doing a podcast about this town I live in now too, and interviewing people. And I was like, well, what if we say something and somebody doesn't like it? Like, well, that restaurant's tacos suck or whatever. Like these are like, it's a small town I live in now. It's like maybe those people wouldn't like that too much, and I might see them somewhere. So anywho, I think everybody's gone. So I'm gonna hit the stop button, you guys. Nice talking with you, and I hope Andrew's somewhere out there. I think he's busy. I don't think he was coming back. So I'll see you guys later. Thanks, Alejo. See you guys later. And like I said, feel free to send me an email or whatever. Try to find me. If you send me an email, I can tell you how to contact me on Facebook or whatever you preferred. The only one I don't do now is IG, because IG kicked me off like 3 times, and it's just getting tedious. And so, I mean, I guess if I stop posting mushroom stuff, but I don't really do the IG. Like I don't scroll on IG or whatever. So anywho, I got enough social media already. So I'll talk to you guys later. Bye-bye. If that's maybe bye, maybe not goodbye. I don't know. Maybe Andrew shut it down already. I don't even know. I don't know what's going on. There's another window. Oh, there it is. Okay. I think we're still going here. Let's see. I think I have to exit, leave studio. Okay, there you go. Bye-bye, you guys.
All right, guys, for those of you who are left, sorry I missed that last little bit. I got a phone call right there at the end that I had to take. So that was an excellent class. I got to enjoy the vast majority of it, thankfully. And I really hope you guys did as well. Thank you all very much for sticking with us and enjoying the class and learning some stuff. And for anybody who needs anything, make sure you email me at mossycreekmushrooms@gmail.com. And with that, guys, I think I'm on vacation. Keeps on culture. I'll see you Thursday. No, Friday. Friday's the live stream.
Yeah, they said the creek was quiet until I showed up with the flash. Now it bubbles like a cauldron full of chaos and sass. Flip the switch, boom, spores light the night. I'm that mad mycologist, cooking dynamite. Roll up in the lab coat, looking like a villain. Petri dish, pimping every strain I'm killing. Got that mycelium feeling spreading in the ceiling. Dr. Solerian sermon got the culture kneeling. Moon pearl shimmer while the flask gets hot. MCM, baby, we the cream of the crop. I mix oats and sawdust, make that block ignite. Fun guy fireworks, call it Friday night. I'm a spore bomb lighting up the scene. Grow bags popping like a fever dream. Got jars on the table, culture's clean. Dr. Silurian cooking up that green. Ooh, Mossy Creek, that's dynamite. Ooh, spreading spores till the stars take flight. Ooh, call the lab, tell them brace for blight. Cause I'm blowing up the world with my mycelial might.